Hey guys, welcome. This is Nilesh. I see lots of people coming in, trickling in, and we are about to start in just a few. We are recording this session. Our state law requires that we tell you very clearly that we are recording this session, and we will be doing that. We are actually recording in the cloud. We'll prepare a video file at the end of the video and end of the session, and I will be posting that video on the website. I'll tell you where exactly I'll post it. On the learning pathway where you see cloud technology section, that is where you will see the recorded video at the end of the session. Today at 7 o'clock my time, we have people from 3 countries in this group. We have people from US, there are 20 of us. There are 2 people from Poland and 1 from Singapore. They are all here. So why don't we just take a moment and introduce ourselves, beginning with me. So let me do that. My name is Nilesh. Hi guys. I run Cloud Genius as a private educational institution licensed by the state of Washington. I have a funny accent, Indian accent, I call it. It is funny. It may be different. So if you find it hard to understand my accent, I would request you to please let me know that I need to repeat. Sometimes I say some words in a different fashion than most others. If that's the case, and if you do not understand my accent, please tell me so. As I said, I am your friend, not a professor. I happen to be running this program in partnership with a college, like Bellevue College that you know. Sometimes we run with other colleges. If I am speaking too fast or too slow, you need to tell me. And over the course of a couple of days and couple of sessions, you will come to know of my accent and my ways of talking, so you will not have this problem. But very likely, the very first day, you will run into a problem where you cannot probably understand me. If that is the case, I need to know. I need to ask, you need to ask just clearly, hey Nilesh, stop, slow down. Or hey Nilesh, this is very trivial, speed up, go fast. Or maybe we know this already, you can skip. That is also okay. I have the ability to switch topics on the fly. I do not use a set agenda or a set PowerPoint. I don't have any. We don't have an exam. You probably know this already. So what we do is focus primarily on your area of interest. We will cover the fundamentals, cover the ground, cover what the industry is doing with all the big companies, Microsoft, Google, Amazon, and all the small players. We cover the definition of cloud computing. What is it? We go through great depth. But then I will not drive you to one specific direction that you do not want to go into. So there are lots of people. We have 23 people plus 2 of us. And you get to choose the area that you want to dig deeper, and I will help you in making sure that I will basically answer your question, help you complete whatever you're trying to accomplish. We have a ton of exercises to do and follow along. You need to do that as we proceed. But again, at the end of every segment, like we have 3 of them, technologies, DevOps, and architecture, those 3 segments. At the end of every session, there will be a certificate generated that you need to upload to your website, to your employer, so that they will know that you have a certificate, so that they will not deduct from your salary. Those kind of things, you need to make sure that you're doing it properly in time so that your employer is happy. Having said, our goal is not on getting a certification. Our goal is to actually learn, to actually make use of technologies, to understand what these things are from the industry and how do we identify best of breed products and couple them with open source projects. That's going to be the overall focus of the program as we go through these 3 segments, technologies, DevOps, and architecture. You know that already. I'll go deeper. Now, having that brief introduction, which was not really brief, let's go switch to the next person on the list that I have here, which I think we'll go through what I see right now on the display. I'm looking at, the name is Troy Collier. Hey, Troy.
Hello.
Hi. Please introduce yourself.
Oh, great.
Just take a short intro.
Troy Collier, enterprise architect at Boeing.
Sweet. Yeah, keep going. If you're done, we'll go to the next one. Next one is Lane. Hi, Lane.
Sorry, it took me a while to unmute. I'm Lane Kokas, and I'm an application developer at Boeing, and we're going to be rewriting the functionality of an in-house application into a cloud-based application, and so this.
Sweet deal, sweet deal. Yeah, we'll do that. We'll do some of these exercises. How do we take a real, monolithic application, convert that in, break into parts, and run into some kind of a containerized environment? We'll be doing such exercises later on. We'll actually have hands-on exercises on this idea. We'll do that. Thank you, Lane. Paul Becker. Hi, Paul.
Takes a second to unmute, sorry.
I know.
Hi, Paul Becker. I work for Boeing as well. I see a lot of Boeing names on here. I'm in Enterprise Cloud Solutions, so I work with Mick Pegg for the people that are on here that know him. And looking forward to the classes. Thanks.
Thank you, Paul. Thank you. Next one is Tim, Timothy Mumford. Hey, Tim.
I work in the storage architecture design at Boeing here in Charleston. Just here to kind of get an idea of how cloud works and use it to more apply towards my job and kind of advance my career a little bit.
Sweet. Thank you, Tim. The next is Travis. Hey, Travis.
Hi, everybody. I'm Travis. I took the last course that Nilesh offered in the fall, and I used to work for Boeing. I was a former service engineer, field service rep, and then finally a little flight test there. And I've decided to transition into a different job here, a different sector altogether. And yeah, so I just pushed out a little Terraform package onto GitHub, and I feel like a real coder. So that's what this class did for me. I hope that you guys get something like that. I'm proud to be here watching Nilesh and maybe participating as like a little bit of a TA. We'll see how that goes. But
yeah, I think yeah, thank you. Travis is has done a tremendous amount of work. He's transitioning, as you heard him say. He has picked up quite a bit of skill and new techniques and technologies using open source, and he'll probably demonstrate some of that his work to you. It is available in the open source, and so we'll have an extra session just focused on. If you're interested, you can participate in that. We'll do that. Thank you, Travis. Next one, we will have. Let me say the name correctly. The pronunciation is Vukash. And he is next. Hi.
Hi, I'm Lukasz and I'm working in the IT industry at the moment as a sales, more in hardware and object storage, more or less close to the data center.
Awesome. Thank you, Vukash. Next is David. Hey, David.
Hi, I'm David Kokas. I manage the virtual machine services at Boeing under Enterprise Cloud Services. And I, too, work with many of the people that are in this class this time. So look forward to working with them in this way and also learning a whole lot more. Even though I manage virtual machine services, there's a whole lot I don't know. So really looking forward to this.
Awesome. Sweet deal. Thank you. Justin. Hey.
Hey. Hi. My name's Justin. I'm also a Boeing employee. I do application development. And really looking forward to the course and seeing how all these different tools and form into a tool chain.
Awesome. Thank you, Justin. Ramesh.
Hi.
I should say he's Lieutenant Colonel Ramesh from Indian Army.
Yeah. I served in the Indian Army for just about 2 decades or so. And thereafter I moved to Oman and I was working there. I am a civil engineer by profession. I had taken a sabbatical and moved back to join my wife in Singapore. And that's how I want to do this course so that I can transition from Oman to, let's say, Singapore. That's it.
Thank you, Ramesh. Next is Trey. Hi, Trey. I think I need to unmute Trey. So, yeah, he did. Yeah, he did. Go ahead.
Hey, my name is Trey Hill. Work for Boeing as well with Storage and Backup Group. Taking this class to advance my knowledge with the cloud. So I'm looking forward to it.
Thank you, Trey. Next is John. John Slater. Hey, John. You need to unmute. Let me do that for you. Yeah, you're unmuted.
Hey, John Slater, Information Security at Boeing. Can you hear me? Okay.
Yeah. Yes, keep going.
I didn't know if this thing was working. Yeah, Information Security Integration and Architecture team. And we're working with all the cloud players as they're rolling things out, and we're developing all the cloud infrastructure. I personally am working with the analytics group, and they have a platform they want to move to the cloud eventually as we get going. And so that's my personal role at Boeing that involves the cloud right now.
Sweet deal. Next is Chad. Hi, Chad.
Hey, I'm Chad Shear. I also work for Boeing. I am working in the.
Your microphone is away from you, so please go closer to the mic. Thank you.
I work for Boeing. I am working the Object Storage Initiative.
Thank you. Thanks a lot. Next is Kevin. Hi, Kevin.
Hello, Kevin Johnstead. I'm a storage technology architect and I work for Boeing.
So Kevin is the person, I think, who gave the foundational storage backbone to Boeing's OpenStack, is what I understand, Kevin. Is that right?
The block storage end of it, yes. Chad is working the object storage end of it.
Okay, so Chad is the object store person, and so you're using Ceph. Is that the idea? Are you using Ceph as a part of OpenStack or something else?
No, we're using currently using Dell EqualLogic.
Okay,
for block.
so Dell's storage solution, I see. Okay, yeah. The project that Travis mentioned is actually something of interest to you. It is a part of OpenStack solution called Ceph, C-E-P-H. So he'll talk more about that later another time. Thank you, Kevin. Next is Dave Savage. Hi, Dave.
Hi there, Dave Savage. Yeah, I'm also at Boeing Information Security, Architecture, Integration. So I've been around quite a while, know all our information security infrastructure. But currently we're working on some of what we call second century, or some gigantic projects that are out there in the enterprise space.
Thank you, Dave. Next is Piotr. I hope I pronounced his name correct. I practiced.
Okay, hi, Piotr. I'm working as a sales manager in a quite big Polish IT company. We sell our own software as a service, and we've got our own data centers, and we also sell lots of hardware, connected with our software.
Thank you, Piotr, joining. I know it is like late in the night, middle of the night for you, 1 o'clock a.m. And I appreciate that you are there online. Thank you. Next is Kyle Miller. Hi, Kyle. I cannot hear you, Kyle. I think we have an audio problem. We need to fix that. Cannot hear you. So we'll fix the audio later. Let's move to the next person. I think is, the orders went all the way off. So did we cover? I cannot hear you, Kyle. So sorry. We did discuss. Next is Kevin, I think. Kevin, did we talk to you already, right? Yeah, I'm so sorry. I think we did. So Chad, we spoke. Josh. Next is Josh. Hey, Josh, are you still there?
Yes, I'm here, and this is Josh. I'm working on the Boeing on the RDS side as a developer.
Okay, nice. Nice. The RDS as in Relational Database Service?
Yes, correct.
Oh, nice. Beautiful. Thank you. Next is Alexei. Hi, Alex.
Hi, my name is Alexei Kramer. I also work for Boeing. I'm in the enterprise architecture, and I really need to keep up with the technology. And Boeing is moving towards cloud quite heavily. And to perform my job duties, I need to be aware of the cloud facilities and be knowledgeable in the terminology and understand how all of it works.
Thank you, sir. Thank you very much. Next is Yanli. Hi, Yanli.
Hi, this is Yanli. I'm an enterprise architect at Boeing.
Nice. Nice to see you. We have the next online is Sue. Are you there?
I'm here. Can you hear me?
Hi. Yes.
I work for Boeing, and I am in the database group. Also, I work do the cloud. I work on the cloud database side.
Beautiful, beautiful. Next is Val. Hi, Val. Are you there?
I am sorry with the unmuting. Can you
No
hear
worries.
me?
Yeah. It's first time you know where the buttons are, so it's okay.
I did it like 3 times. It took a while. Anyway, I'm with Enterprise Cloud Services at Boeing, along with a couple other folks on the class.
Some of your teammates.
Yep,
Nice.
I'm new to the organization and just looking for an opportunity to build a foundation and learn as much as I can.
Beautiful. Thank you. Next is Jerome. Hi, Jerome.
Hello?
Jerome, are you there?
Can you hear me?
Yeah. Yes.
Okay. Hi, this is Jerome. I also work for Boeing. I'm in information security as a security architect. And working with a couple of my partners on the call here. So we all decided to join, Dave and John. So,
Nice. Very nice. So I'm trying to figure who's from which group, because I know so many people and so many of you, and I'm trying to connect who knows who, and so I can maybe figure out one day. And I think that'll be like a couple of days. Thank you, Jerome. And next is, I think, the last person on the list. I hope I'm not missing anybody. Rob B is the next one.
Yeah, this is Rob, and I actually work on David's team. He's my lead. I am new to Boeing. But I come from a software development background, and from both GE, which is energy management systems and power systems, and then before that, SaaS, internet companies, and I do a bunch of stuff online at home for open source and paid source that I've run. So what I want to get out of this is just everything new that's coming down the line, so that we can look at how that's all going to integrate with both Boeing and public cloud in the future.
Nice. Awesome. By the way, Rob is a developer. He writes applications he wrote applications for Android and iPhone. You can see them on the App Store. He'll give out the links later on. You can find him or find the links on App Store if you're interested. Some nice games you can find out. I tried it and I liked it, so I'll play more later on, not right now. So, okay, did I miss anybody? 25 people, that's it. So yeah, I hope I did not miss. So what I will now do is I'll switch my display away from the camera to my desktop. So you should be able to see my desktop screen coming up in 3, 2, 1. Here we go. And now here I see a white sheet of paper, basically blank sheet. That's what we are beginning with. And in that blank sheet of paper, what I'm trying to accomplish is basically describe what we want to cover, what is the plan for today and the upcoming days, few days up ahead of us. So beginning with, I want to understand in this cloud technologies segment, we have the next one will be DevOps, and after that will be architecture. Our focus here is breadth, like breadth of the industry, breadth, and that's good. And we use open source tooling, we'll use cloud services vendors, we'll understand and go deeper in this idea about what the industry provides using open source solution sets. In this segment, we will cover tools like Ansible, Chef, and Docker. And then we'll apply these tools. So this is the depth coverage. And we'll take the breadth and depth from here and apply that to a customer scenario from a case study point of view, understand architectural design requirements, and implement a solution for a given customer. So we'll work on exercises that will enable that. And we'll keep the module structure somewhat flexible to you, depending on your areas of interest. At any time, if you feel that I am giving you work that is boring, you should tell me that, hey, Nilesh, this is boring. Don't make us do boring work, because that is not what I do. If you find that there is some exercise that is silly and trivial, don't do it. Don't waste time. We don't have much. So I want to focus on only the good parts and stay focused just on that. If at some point, if I give you an exercise and you find that it is silly or trivial, just say, I'm not doing it. That is okay. Because I know, and I trust you. We are dealing with professionals in the industry. This is not a kindergarten, high school class. So we understand this. Having said, let us focus on this idea of technologies. What do we want to cover? So in the technologies segment, what I want to begin is define cloud computing. Like, what is it exactly? Who defines it? And then we go into depth of the definition itself and understand what are the 3 service models behind this: infrastructure as a service, platform as a service, and software as a service. These 3 service models are defined in the definition itself. So there is a definition. We'll talk about that. There are 5 different characteristics. So 1, 2, 3, 4, and 5 characteristics defined in the definitions. We'll understand what that means, understand and do some examples, exercises in terms of what does that actually translate from a practical usage point of view. We'll see these things, we'll understand, discuss, and we'll also look at this site, which has, if you know this site, which you probably have a login already for, you will be able to see that it has a lot of content available in the technologies section right here at the technologies button, right below the logo, where you see that, this logo. Right below that, this technologies button is where you should click. And then you will find that there are lots of reading material available for you to read, beginning from the very first one. Why do businesses care about cloud computing? And this is a short video. And then there's some write-up. Now, I'm not playing these videos right here because they are available to you already. You can watch it whenever you feel like, before, after, but hopefully not during the session. But that's the content available. And if you keep clicking through, there are 90 such lessons in the technology segment. You should be able to watch it as and when you feel like. Just go ahead. Don't wait for me to cover it. Just proceed ahead and finish through if you can. That's welcome. I actually encourage that. You go through the entire material on your own without waiting for me to cover it. I will cover it absolutely. But don't wait for me. Proceed ahead. If you have time, just watch through. Having said, if you go back to the technologies page and scroll to the very bottom of it, in this bottom section, you will find there are these video recordings from sessions. Now here, there's a new button showed up today called Winter 2018. And if you click on that, it is empty. It is empty because the recording from today will show up here tomorrow. That's the placeholder where I will be adding this current recording. Whatever we are doing right now will show up here in form of a video. If you go to the next lesson, you will find recordings from videos from fall 2017, like September last year. We did video series just like this, live videos with people like you. And here are the recordings. They are available to you. There are all of them. The entire content for last so many years, we have recorded and accumulated them here. You can watch these things. You may find it boring because you did not participate. So I don't expect you to watch them, but I just want you to know that you have access to it. The current one, which is happening, will show up here in the Winter 2018 section. Now, let's go back to that write-up. What I was describing is that these 3 different service models and these 5 characteristics, they're defined by somebody. Do you know who defines this thing called cloud computing? Who defines it? Do you know? At least, let's say in the US, do you know who defines this? Cloud computing, the term cloud computing. Do you know who defines? It is not me. I don't define it. It is not Microsoft, not Google, not Amazon. None of these companies do, but the organization that defines standards for US is this organization. At least in our country, in the US, this is the organization that most people in this country follow. Other countries have their own standard institutions, but they generally collaborate with each other and try to come up with a global definition. So this is the institution that, at least in US, people tend to follow. And let us go find out what is the definition that these guys have come up with. I would like to caution you with that fact that this definition that they have is a little bit old. And old means stale, means can be incorrect a little bit, not too much, but just a little bit. And you will find out where it is incorrect by instinct, you can tell. But let's go see the definition itself. How do you find it? My best way of operating on the internet is to not remember anything. I do not memorize anything. What I do is I Google search all the time. Like for example, NIST and definition of cloud computing. So they should be right there. That's how I find. That's how you should also find. So here is the definition. But by the way, I have already put a link for this in our forum. So if you can go back to the forum on our button here called forum, you should be able to find a link to the fundamental section and a cloud computing definition. There is this link, which actually goes straight to the definition provided by NIST for what cloud computing actually means by the US standards. Other countries will have different standards. For example, I don't know exactly what Poland's definition is, or if there is a different definition from what they have here in the US definition. I think generally speaking, this is an okay definition. There are some issues that have come up recently. We'll describe that. We'll talk about it. By the way, this document, which you have the link on the forum, is a little bit boring to read. It is fairly long and it can be boring. So I don't want to go through the whole document. What I want to do is straight focus just on the definition itself and help you understand, interpret. And we'll not spend too much time on the definition because that is not going to be very productive, because it can be boring by inherent, the idea that we are talking definitions and pedagogy and that's not my style. So we'll spend some time on it, but not too much. So coming straight to the point, here is the definition in these words. And that's the blue highlight that I just did. That is the definition. So let's go focus on just those 3 sentences or 3 lines with actually 1 sentence and read. What is it? What is the definition they're trying to say? It says it is a model for doing what? It's model for enabling something. Enabling what? Enabling on-demand network access to something. That's what it's enabling, right? Cloud computing is going to enable on-demand, ubiquitous, convenient network access to something. We'll talk about what that something is later on. But let's figure out what these things are. Ubiquitous, meaning it doesn't matter which country you are in, whether it's Poland or Singapore or India or US or whatever, Zimbabwe. As long as you have access to the internet or some form of network within your private network, some network connection, you can get any location. As long as you have the network, you can get convenient and on-demand access. Convenient as in, you don't even have to get up. You can just click a button and you get access. That's convenience. On-demand meaning whenever you feel like, I want it right now. And so say, for example, I'm just going to pick on your company, Boeing company. You want a machine, you will order, and then you will receive the machine in a couple of days, sometimes a couple of weeks. That doesn't happen in the cloud. You make a demand right now, it will be given to you in a matter of few seconds, maybe a minute or maybe 10 minutes. That's it, depending on how how fast or slow the provider is. But in a couple of minutes, you should be able to get your resource. That's the core idea. It is on demand and convenient and ubiquitous. It doesn't matter whether you are in US or you are in other country. As long as you have access to a network, you can get access to some resource. That resource is what we are actually talking about. Access to what? Access to a shared pool of configurable computing resources. That's the portion that I'm describing about the pool of shared resource, meaning you and other people, can share the resource. And the idea is to be able to share resources, meaning, you can have, let's draw a picture. So here is the resource, for example. And there are these 2 people, A and B. You want to share the resource. And you want to give, if they ask for it, you give the resource to them. You give a portion of that resource to this guy. So A and B are sharing this resource. So this is one person, this is another person, and they are sharing the resource. So just shared access to a shared pool of resource. People are sharing, getting it on demand. That's the idea. You're sharing it. And what are you actually sharing? Computing resources. They are configurable, meaning you can make them bigger, smaller, adjust properties, adjust characteristics, adjust performance criteria. You can set and parameters that you really exactly want, and then order it and get it right away, immediately, ubiquitous, any location, conveniently. What resources are we really talking about under the hood? We are talking about these things, like, for example, networks, servers, storage, application, and services. These things. That's what we're really talking about. When I say resource, I mean network connectivity, CPU, storage, applications, databases, or other services related to computing that you can put things together in form of configurable compute resources. That's what we are really sharing. And you are making it available ubiquitously, conveniently, and on demand as long as the user has access to a network. That's the core idea behind it. That's one part of the definition. So we discussed these 2 lines. The second part of the definition is it can be rapidly provisioned, meaning I want it right now, you get it right now. There is no purchase order involved. There is no delay of approval involved, because everything is automated through a API call or a click of a button or using some command line. One of those methods. You should be able to get rapidly the resource you need, rapidly provision, and rapidly release. You don't want it, you get rid of it. Your bill should stop. By the way, this is on pay-per-use basis. So we'll describe those things also, but with minimal management effort. You don't have to go talk to the boss. You don't have to go even call the service provider on a phone call. Like I call some number in India, somebody in India responds. That's not the idea. like no phone call needed. You don't even have to bother the service provider. Don't even have to involve your boss or your management team. Just need the resource, get it, and you move on. You use it, you're done with it, you release it, you're basically done. The transaction is complete. That's the idea of using shared pool of network, server, storage, applications, and services that are you sharing with other people, just like this picture tries to draw. You're sharing these things with multiple people, A and B, and let them access this on demand as and when they feel like. That's the core idea in the definition as described here. Now, let us read the other parts. In the other part of definition is like there are 5 essential characteristics, 5 of them, and 3 service models, and 4 deployment models. So let's go understand what this quickly. The 5 essential characteristics, those are right here. 1, 2, 3, 4, and 5. Let's go understand them very, very quickly without actually reading this. I'll describe that to you. You probably know this intuitively, but I'll make it clear. You can read the definition if you like, but that's not what I'm doing right now. I will be actually just describing to you what this on-demand idea is, which you already know. It is self-service, meaning you don't have to call anybody, right? No phone call needed. So if I want a machine, I want it right now, what do? I open a browser, I go to a website, and I have given my credit card to them already. So I just log in and get my login succeed, and I will get a token for me to go forward with this. So I'm logging in right now. So here I log in. Now this is a cloud company, and I just want to describe to you the idea, which is on-demand self-service. That's what I'm talking about, right? On demand. I feel like I need to have a machine right now. Can you please give it to me? So these guys apparently call their machines as droplets. That's what they call it. It's a fancy name for a machine. The company is called DigitalOcean, right? So it's a droplet in the ocean. That's what their terminology, their marketing, right? The droplet is basically a computer. That's what you're getting. So create a droplet. That means you create a machine. You have to decide what type of machine you want. That's what I'm going to do in the next page is I will say, give me an Ubuntu machine like this one, 64-bit, and I will spend only $10 an hour and give it to me in maybe San Francisco number 2. And I would like to use my key pair. And I say, click the button, green one, create. That's all it takes for me to describe that I need a Ubuntu machine right now in San Francisco, ready for me in the next 50 seconds. And you will see that this machine becomes accessible to me as we go. That was the on-demand self-service thing that I just demonstrated to you live.
Nilesh, I got a quick question. Do you know of any service out there that, so right there, you're focused on the actual machine. And one of the things that I'm looking at is, I don't care about the machine. I don't care about the infrastructure at that level. All I care about is, as a developer, I want to have a Docker image that has my application components on it. Do you know of any service that provides that kind of, the PaaS?
Yes,
or
we'll
even
get there.
it's even maybe even SaaS. Do you know of any services that provide that level?
Yes, there are. There is
Okay.
one in your company right there with you. It is called Cloud Foundry in your company. It's there.
Okay, great.
Right? And other outside, there is Heroku. There is Amazon has a service. Microsoft has a service. Google has a service. We'll get to the names. But right now, at this moment, I am dealing with this thing, infrastructure as a service. That's why you saw machines and all that, right? You saw that I got a machine ready for me, and this is the IP address, and I can copy it. And let me just copy the IP address. There we go. And I can go to the command line and just connect to the machine on demand on the fly like this, SSH, and say root at IP address. And here I go connected. Okay, hold on. Let me just add my key. And then I connect. So I am now connected to the Ubuntu machine right there. You can see that here is the machine called Ubuntu. And you can see the details of the machine right here. So this is the Ubuntu machine I just started like a few minutes ago. You can see the uptime. It is like a minute ago, right? I just booted it up. So we got this machine on demand, and we just demonstrated this idea of on-demand self-service with an infrastructure as a service example. We'll get to other examples. We'll do hands-on exercises with almost everything. I don't do anything without an exercise. I have to have something to show, to actually show you live with a real cloud out there. That's what I will be doing almost every single time. So you just saw me, one example, on-demand self-service. Now, when I feel that I don't need this machine anymore, what do I do now? I say, I don't need you, bye-bye. How do I do that? I say, go here and destroy the machine for me. And the machine is now, come on, destroy, and say confirm, the machine is dead. There we go, destroyed. Now I don't have any droplets, which means my bill stops to 0 again. It was charging me some money for some minutes, but now it is not. That's the idea of on-demand and self-service. Did I make a phone call to the company? No. Did I call my boss? No. Nothing. None of that. So that's the on-demand aspect. That's how you expect on-demand self-service to be. Next one, broad network access.
Just I want to ask you, this is generally a rental thing, not a capex or not a capital thing.
Yes, you're right, sir. Absolutely. In fact, that's a good point I should mention. Cloud computing is like renting somebody else's computer. It is not buying. When you buy a computer, you own it. And that is a problem. That is a fundamental economic problem that this cloud computing tries to solve by renting it. Let's go see an example. Here, this is a car. It is $150,000. If I want to buy it, I'll have to spend the money up front. This car is also available for rental. You can go to Hertz Rental Car, and they'll get you the rental car for like $100, maybe $200 a day, or sometimes more. You can get the car, the experience, the benefit of using this car. It's a Tesla. You can use it, and you pay how much? $150 a day, sometimes $200 to $300 depending on the model. But you don't have to spend like 150 grand to begin with to own the car for using like a day. That's not what the idea is. So it helps you, and I'll describe more of the economics behind the scenes as to why it is important. Why is it that, in fact, the very first lesson in the lesson plan actually goes through the economics of this idea. If you go back to the cloud technology segment, the very first thing is, why do businesses care about cloud computing? That's the first thing that you will see here described already in this video. Why do businesses? So you can read that later on. I'll move ahead. I expect you to, by the way, follow through that learning sequence and watch the videos, do the things that is described there. And if you find it boring, don't do it. Just tell me I will not do it. That's okay. That's totally okay. I don't expect you to do every single thing, but I want you to read through and watch through ahead and figure out what's interesting, and you pick the interesting parts, take the interesting ones. Don't bog yourself down with unnecessary grunt work. Don't do that. I don't do it. I don't want you to do it. So learn to say, no, I will not do it. Learn to tell me that, Nilesh, you are boring us. Please do that. I will actually thank you for telling me that, because I don't want the program to be boring. I want it to succeed. And that's the reason why we have such a large number of people join us every single time we run, is because people like it. People like, your friends must have told you that the program is good. That's why you showed up, and I want to thank you. And it is with your feedback that I can continue to improve the program. So if you tell me that this part is boring, please stop it. I will absolutely thank you for that. I will cut it down and cut the boredom and keep it interesting. That's my goal. I will make sure that, so please help me succeed. Next one, broad network access. I think this idea is very intuitive. As long as you have access and wherever you're going, you can connect to this company or some other company. By the way, every single company has some method of getting you on-demand access to their resources. What resources they provide will depend on the company as to what service provider you're talking about. Next one, resource pooling. What does this mean? Pooling means sharing. You are sharing the resource with other people. You have the resource, you're sharing with multiple people, A, B, sometimes C. Sometimes there are more people sharing the big resource. You have a big resource. You can share it. How do you share a resource? Under the hood, like this company, when they gave me this machine called Droplet, they gave me some machine size. Let's go see what sizes they have. So we'll go back to the Create Droplet button and understand what sizes of machines do they have. They have certain sizes defined already. We'll go see that quickly. And we'll see that they have these sizes. Let's go see a little bit detail. The biggest machine is 64 gigs, 20 CPU, 640 GB of SSD, and 9 terabytes of bandwidth. It gives like available to you at about $1 an hour, 0.952 per hour. That's the price of this expensive machine. That's a big fat machine, big one. The cheapest one they have is a really, really cheap machine, like $5 a month, less than a cent per hour. This one, it gets you one CPU with 512 MB RAM, 20 GB disk, and a terabyte of transfer. So you have all sizes in between almost. So what does that actually do under the hood? What's going on under the hood? How are they really doing this part of taking a big resource, chopping it off into smaller parts, like divide and further divide, and keep dividing until it gets to a small size that this person wants, and you give it that size. This person may want a slightly bigger size, so you give them this size. This person may want even bigger size, so you give them this size. You're basically dividing a resource into smaller parts and giving it to other people. That's the exact idea that we are doing in our VirtualBox, right? You have set up VirtualBox already. This is starting up. You have seen that this virtual machine, VirtualBox that you have is actually another computer that runs on top of your computer that takes up about 2048 MB of RAM. This MB of RAM, 2048. Out of the total available on this particular laptop, I have how much? 16 GB of memory. And out of that 16 GB, I have given 2048 MB of memory to this virtual machine. So we are partitioning it. We are creating a 16 GB memory block and divide into smaller chunks. And this is a 2 GB chunk. This is a 4 GB chunk. This is an 8 GB chunk. So you can see how the structure is laid out. And this portion is becoming your virtual machine, VirtualBox. Out of the complete machine that I have in my hand right now is this total 16, which is my MacBook Pro. Out of this 16, I'm giving 2 GB to this virtual machine. That's the idea behind the concept. The concept is resource pooling. We are going to divide a big resource into smaller parts and give it to multiple customers.
Sorry, it's Alexei. Quick question. So behind each virtual machine is actually a virtual machine, right?
There is a physical machine.
Something like VMware or something like that.
Yes, the real technologies used in the cloud are not VMware. VMware is a commercial product. Cloud companies want to save money. They don't want to waste money on commercial software. So what they do is they actually use other open source technologies such as this. KVM is a very popular one. Kernel-based virtual machine. That's what you will find in most cloud companies. This application, it is part of the Linux kernel. That's what people use to create a KVM VM. It is called kernel virtual machine, KVM technology, VM as in virtual machine. That's one very popular technology.
So this works at the kernel level?
Yes, correct.
By pricing all the, okay.
Yes, the other like Amazon company will use Xen hypervisor, XEN, that's the name of hypervisor. The Xen project, this is used by Amazon. It is also open source. Under the hood in Linux, it is a virtual machine provider solution. This is the project that they have modified to use in the Amazon cloud. By the way, I would suggest that I'll give you links on the forum. I'll post links and things to do. I would like all of us to create accounts without spending money with all these cloud providers. So I will have coupons or some kind of a free trial offer for you to try Amazon Cloud, Google Cloud, all the cloud companies. We'll put links on the forum. You will have them. And I would like you to create an account so you can actually play with these yourself. Not just watch me do it, but you should also learn to understand what these things are. And so this Amazon Cloud uses the Xen project. Most other companies use the KVM project. This KVM machine, KVM project for virtualization, and the commercial product that you just mentioned is VMware, which is what your company probably has, a VMware cloud internal to you, which is what this product is. So that is in Boeing company, they have a VMware cloud. You have it. You also have another internal OpenStack based cloud, which is what I think Kevin and others are working on. So that is a completely open source cloud, but this is a different cloud internal to you. You have it. That's why I think most people in Boeing are familiar with the VMware part. but KVM is what is extremely popular, and Zen, which is the open source variations to this. So that's what we are dividing a resource into smaller chunks and giving it to multiple people. So under the hood, these companies, let's go to Google search again and see if we can find a cloud, data center rack. So here's a picture of something that you will see. You may have seen these kind of machines, probably. You might have it in your office. So this is the actual backbone that you will find in the cloud companies, that they will have such things layered on top of, machines after machines, floors after floors, in buildings after buildings, in multiple locations worldwide. That's what actually the cloud looks like from a real physical perspective. And then you take these big boxes, you divide them up pretty much like what I'm drawing like this. Like I divide the MacBook Pro into a small VM called VirtualBox. And this is your Cloud Genius workstation with 2 GB RAM. Or sometimes some of you have given a 4 GB RAM because you have more memory. That's okay. But that's how you divide a resource and you share it with other people. That's the idea under the hood. So the resource pooling, I think you got that idea. Let's move. Elasticity. What does that mean? Elasticity basically means something like this. I'll draw with a picture. So here is my, let's see if I can make it big, like that. So on the bottom of the screen, you find this computer here, and this another computer here. And I want to get more of these guys. So I'll say, okay, I need one more right now. So I get allocated from the company. And so I'm the user of these 2 computers. And as you saw me do, create a machine with click of a button, I can basically do one more machine by saying that I need one more, or maybe 3 more, like that. So I get 5 machines of various sizes I want. And so you can very easily and quickly do this by cloning or creating new machines just like that. So I say, I need more. So I say, paste, 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 like that. You can get a ton of machines like that. And when you don't need it, you can get rid of those. How do you get rid of those? Basically delete them. How do you get rid of this? It will be like this. So you just delete the machines, they go away. You want them back, you just bring them back. You don't want them anymore, you let them go. That's the idea behind elasticity. You can grow and shrink your number of machines at your disposal. This kind of shrinking and growing is one way to shrink and grow. There is another way to shrink and grow, and I'll demonstrate that picture again. The other way of shrinking and growing is like this. I grew my machine to a big box and I want to make it small. So I adjust my machine size to be appropriate to my application. This is another type of scaling. You saw 2 different ways of scaling right now. I'll describe this idea further and I'll define some terminology. I'm talking about scaling and elasticity. There are 2 different ways of doing things. One of them is called scaling out and in. The other one is called scaling up versus down. When you have a small box and you make a big box, that's what a scaling up is. Whereas out and in, it means when you have a box, you want more, you get more. And you don't want them anymore, so this was scaling out. You don't want them anymore, you scale them back in. That was scaling in. You save money by scaling in, you shrink your infrastructure. You scale down by going smaller like this. You scale up by making it a big fat machine, as you saw in the picture. And that's the idea behind scaling. And there are 2 distinctly different types. There is another way to say the same thing. This idea is called horizontal scaling. And this idea is called vertical scaling. I just want you to know that there are 2 different ways of describing scaling, and it depends on the underlying application as to what type of scaling is more appropriate for a given application. Most of the time, people talk about scaling when they mean this, scaling out most of the time, and scaling in. That's what they generally talk about when they say scaling. Sometimes this is also necessary. Scaling up and down, vertical scaling is also necessary. So that part of scaling is the ability you get when you have the cloud provider give you rapid elasticity. You can scale them out, scale them in, or scale them up, scale them down. Any questions on the elasticity aspects? Probably not. If there are questions, feel free to pause me. Just say, hey, hold on, let me ask this question, or just interject, no problem. As you have seen me, I don't have a set way of working through a PowerPoint slide deck. I don't have them. I don't need them. I don't want them. I have found that PowerPoint bores people. I call it death by PowerPoint. And I don't do that. Don't have it. I mean, I don't even have a PowerPoint slide to give you. So don't ask for it. I will have the write-up that I have, this whatever I'm writing. I will give you a PDF file. I'm not sure if this is interesting to you, but that's what you have, my handwriting, and you will get it if you like it. If you want it, I'll give it to you. But there is no PowerPoint. Having said, the last one is the fifth characteristic, number 5, is the most important one, which is if you use a service, you are going to pay for it. As simple as that. This is what measured service means. Measuring how much are you using. It is like meter. Like you take a taxi in a big city, the meter starts and you go travel, and then you're done traveling. The driver will drop you off wherever you want to get off, and the meter stops. You pay the bill and you move on. That's your travel. That's what your value is. Did you want to go from A to B? So you went there and you pay for only the use of time that you use in the travel mode of transportation. And the person who's driving the car, the taxi, is actually measuring your usage and is charging you a predetermined rate according to a predetermined contract that you have. If the contract is implied in the fact that you're taking a taxi, but there is a contract with every cloud provider. Like I showed you this example, and there are, almost every cloud provider will have a contract. You have to follow that contract and make sure that you don't violate the contract, because if you do, they will kick you out. And you don't want that. Yes.
Nilesh, this is Rob. I'm reading the definition here, and it's a little bit, I wonder if it's applied more broadly, because you're talking about contracts, but has it ever been applied to the sense that it relates back to the elasticity, where you're monitoring the level from either an application, mostly an application in my example, that you need to have a service that allows you to measure when it needs to expand out either horizontally or vertically and then shrink. Is this point here ever applied to that situation?
I think if I paraphrase your question, you're talking about what is known as service level agreements.
It's a little different, because what I'm seeing here, the SLA is a little different, because that's usually, again, relates back to the contract. What I'm saying is measured service doesn't necessarily have to mean contract. It may mean measuring the service of because it says here, e.g. storage, processing bandwidth, user accounts. It's basically the size, and you're measuring that. It doesn't say anything in here about a contract or about paying somebody. It just says optimizing the resources and things like that. And that's why I was wondering if anybody's really applying that metric to other things other than I need to pay for this. Because when I read that, it doesn't.
I think I understand what you're saying. So let me see if I understood you right.
Okay.
So let's go see an example of a case in which you pointed to this definition portion, which I am highlighting it to blue color, that highlight, right? Some kind of an appropriate abstraction, like the type of service, storage, processing, bandwidth, and active user accounts. So that's the blue highlight, which I would like to describe, is what I think you have in mind. How do you measure these things, and how does it relate to a contract? How does it relate to a bill? That's what I will describe now. So first thing, storage. Now storage comes in a variety of shapes and sizes and form factors and things of that nature. But at the bottom line, you have either a fat disk or a fast disk, right? If you have a fat disk, you pay for storage, so $1 per GB. This will be cheap compared to this. This will be expensive because it is a fast disk, right? So the characteristic of being how fat or fast actually doesn't purely depend on the dollar per GB, but also how performant your IO is on the fat disk, which is actually going to be a slow disk, right? It will be a slow disk compared to the fast disk, which is going to be faster. So you get a higher IO per second. And that is also translated into a price. Now let's go see an example. If you go to Amazon Cloud and log in and try to do the same thing like we did with the DigitalOcean Cloud. So I'm going to go there right now, logging in right now, and come on, off we go. So here is me logging in, step number 1, step number 2, and a step number 3. And now I logged in. So here you will see that I'm on the EC2 console, where I'm going to create a new machine, just like I did with the DigitalOcean thing. I launch an instance. This will be very, very complex. So if you have seen it first time, don't worry. I'll strictly focus right now just on the storage aspects. I'm picking some Ubuntu Linux right now, right here, and say I want to review and launch a machine. So I want to configure the instance. And I will say, you know what, add some storage. And let's focus on the storage idea. In here, you will find that the drop down here gives you 3 different types of storage. One of them is GP2 SSD. The other one is IOPS provisioned SSD. And the third one is a magnetic disk. I don't think you will see the magnetic if you log into a new account. I have a 8 or 9-year-old account, so I still have the magnetic option. I've seen some of the newer accounts don't even have the magnetic option. So the real discussion actually remains on the 2 ideas here. So the GP SSD and the provisioned IOPS SSD. Let me tell you that this provisioned IOPS SSD is actually more expensive as you increase the IOPS number. You can actually get a higher performing disk by asking for a speedier disk like this. I just made it 4,000. You can go even higher a little bit, maybe up to 6,000. And if you ask for a higher performing SSD, you will get a slightly higher bill. The machine will perform better with a speedier disk, and you don't have this choice if you select the GP2 SSD. You get what you get. So that's the idea behind under the hood, fat versus fast disk. And if you translate this discussion back to the definition portion here, you will see what I'm talking about now. When it is being measured, they are not only measuring the size of the disk, they're measuring the performance of the disk and other characteristics as to how much are you using, how much of the usage of a storage resource that you may have. And that doesn't apply to a disk, because if you typically take a disk, it is like you may order a 100 GB disk, or you may order a 32 GB disk, depending on your usage. But when you're using other types of storage devices, which we'll get to very soon, this discussion doesn't apply, because you can actually store as little or as much as you want. And so the price you pay is actually $1 per GB, depending on the class of storage, the service level of the quality of the disk underlying. So it will perform faster or slower, perform in a fashion that will give you cheap storage for a lot less money compared to the other disk. So that's just a disk discussion. Next one we have here.
Thanks. That answers the question. Thanks.
Sweet. So there are other characteristics like performance, bandwidth, active user accounts. So you can go deeper in. Everything has a price associated with it, like the number of people using, price. Bandwidth, too much bandwidth, more price. Less bandwidth, cheaper. Processing, high speed, more money. Low speed, less money. That's how it goes. So everything has a metric which basically translates to dollar or some other currency like euro, for example. Or maybe our friends Singapore dollar, whatever the currency is in your country, but that's what you will pay. It is being measured for a good reason, because that makes both parties, the consumer party and the company that provides the service, both of them needs to be happy with the contract. And that is the idea behind these 5 characteristics. On-demand self-service, broad network access, resources are being shared, rapid elasticity. So this rapid elasticity, I forgot one thing I should mention, which I did not, is the idea that this machine that I get here, I can keep on scaling like this and go on and on and on and on until infinity. I mean, that is kind of mind-boggling, but I'm talking about infinity. Now, this is a false statement, because there is no such thing as infinity, right? The world is finite. So you cannot really scale the number of machines to infinity, but the idea is that these cloud companies and the definition tries to give you an illusion of infinity. It is a false thing. We know this. Nothing is infinite. It is finite. Amazon is only so many machines at the end of the day. But from your perspective, it is infinite. Because what happens is if you go to that Amazon thing again and say previous again and say, I want to get a machine. So I'll say cancel, let's go begin again. And this time I'll say, give me an Ubuntu machine. And I want to say, okay, how many I want? So I'll say I can get one machine, or maybe I can get 100 machines, or maybe 1,000 or 10,000, depending on what. It only depends on the amount of money you have. That's the real practical limit. There is no such limit that I have run into with Amazon Cloud when I try to get a machine and the machine is not available. That hasn't happened yet. Of 9 or so years of usage, I haven't run into a situation where number of instances that I need are not available in the Amazon Cloud. Maybe my need was small, but I have never heard such a problem. If that problem happens, you just call Amazon. They will create a new data center for you. If you need like 1 million machines, they will give it to you, provided you give them like $100 million. And some companies do that, like the CIA, for example, in the US. They paid like $100 million. They created a separate cloud just for the CIA. Now, we don't have access to it, but it doesn't show up in the list, but I have seen it. It used to be there. I have seen it a long time ago. CIA cloud, government cloud, they just show up in the list. We were not able to access it, but it was one day appearing here. I have seen it.
Neelesh?
Yes.
So how does Amazon give you 1 million machines? Meaning they have to negotiate. They're all pre-created, and they had to sit there and have 1 billion of them waiting, because it does take time to spin up a VM, even minutes. So go ahead. How do they provide millions of machines to millions of people?
So providing millions of machines to millions of people is actually very easy. Providing millions of machines to one company is difficult. You know why? The reason is that not everybody actually uses all. If you have 1 million people and each one of them wants one machine, you know for sure that 1 million people, only 10% or 30% of them will actually use it. In fact, we saw this in when I was at Microsoft. I used to see that. We used to work on storage, and you will have a large amount of storage apparently available. For example, if you go look at this thing, let me show you another example. So we have drive.google.com. So here is an example of a Google Drive situation, right? This is my Google Drive account. Now, if you go look at the settings and say, show me the settings, and it says view details. And here you will find something very strange, really, really strange. I am using how much? 5.3 terabytes of my Google Drive. However, you will see something very interesting here on the right, on the other side. It says your account at Cloud Genius can use what again? Unlimited storage. Now this is hard to digest, but apparently it is true. I have never run into a limit. And by the way, this Google company has given us this benefit of unlimited data storage in Google Drive for free. Can you believe that? Probably not. I did not believe when I first got it. And by the way, I would like to tell all of you that all of you also have access to unlimited storage. Thank Google for that. Don't thank me. They have given it to you also. Unlimited storage in Google Drive. Illusion of infinity. How do they pull it off? How do they actually survive such a case? Don't they waste money like this? By the way, they are doing this to Cloud Genius because Cloud Genius is an educational institution, and they have a policy to give free services to educational institutions like us. So we have it. We have unlimited storage, and you being a student also have the same thing. I will give you have credentials already. You just did not know that there is such a thing. So I just told you. You also have access individually, and this access doesn't expire. Even if the course completes, you still continue to access it. You can use it as long as you follow Google's terms and conditions. You should be okay using this service. Just don't use it inappropriately, depending on, you read what inappropriate means in the Google terms. But this is available to you. Now, how does this thing actually happen in practicality? Are they really infinite in storage? I don't think so. But they know the fact that not everybody actually uses so much of disk. Like I'm the only one in my company that uses this much of disk, but not everybody does. And most of the people in our organization use like hundreds or sometimes 200 GBs of storage allocation. I can see the reports. So I don't see what they have stored, but I see how much they have stored in terms of aggregates. So the usage is like very, very limited, like say sometimes hundreds of GB. This is like terabytes. So it's a heavy usage. But I'm the odd person out. Most companies that have seen aggregate numbers, the actual usage is not heavy. Similarly, the answer to your question about number of machines, 100 million, number of people, 100 million, it's possible. One company like Boeing says, hey, Amazon, can you give us 1 million machines? That will be a complete different negotiation because now you have to actually deliver because Boeing has the ability to actually consume 1 million machines. A person like you and me does not. We are small. Boeing is big. They can consume 1 million machines, no problem. And so now Amazon has to pay careful attention. How do they actually deliver a machine that is a 1 million in count? They have to sit down with Boeing and with the negotiators in your company and their side and discuss the terms and contract and everything as that goes along and prepare ahead of time. And it is not going to be on demand on the very first day. You have to plan for it.
Just a minute. I just want to ask you one thing.
Yeah, go ahead.
This inventory is there, and if it is not going to be used optimally, how does the company even out this? How do they balance out the revenue?
So this is like this unlimited storage to educational institutions is like a charity work. They give it to education.
No, what I'm asking is they have created an infrastructure and they have created so many machines. If it lies unutilized, how does it break even?
Okay, so let's answer that question. So idea is Google Drive pricing. Let's go see Drive pricing, Google. So what's the pricing guide? They charge for the first 15 GB is free. But if you want to get 100 GB, it costs you $1.99 per month. That's the recent pricing apparently. So they're charging people money if they go beyond first 15 GB. So if you store 16 GB of something like picture uploads, you have to pay them a $2 every month. They accumulate this $2 from multiple people across the globe who are using Google services and using Google Drive beyond the 15 GB limit. They collect the $2 per person. But they know for sure that this number, they are able to actually provide a larger set of services just for the $2 every month. And they can probably run a terabyte solution for everybody, but actual consumption happens to be limited to only 100 GB for this price. So they already inflate the prices heavily. And storage is cheap these days compared to like several years ago when I used to be in the storage company called EMC 20 years ago. It used to be expensive. I used to sell $1 million box. Now it is cheap. Those boxes are not $1 million these days. Storage is cheaper, but even these prices, they might look like cheap to you, but they are inflated. They're heavy. That's the reason why they can afford to give you these kind of pricing that you see here. 15 GB free, 100 GB, $2, 1 terabyte, $10, 10 terabytes, $99. And this is TB plus. So they have a scale going up. And to educational institutions, they're giving charity. So you have it, I have it, all of us enjoy.
Nilesh, do you know if for that free, if they're using any kind of, because we all know Google makes a lot of their money off of advertising and tracking of people and selling what we call interests. Do you know if they're doing that with that free part of the service, and that's how they're able to give that much away for free because they're making money off of other ways, other services, and they just want you to come to their site. So they're giving it away for free because now they're making money kind of in this hidden way. Do you know if that's happening?
That is. I would say that is actually true to a broad extent. You can authoritatively read this detail on the SEC filings on Google. You can see the details. If you go here 10K and read the Google report, they will tell you exactly how they make money, where the money is coming from, and let me tell you, the money mostly comes from advertising. The second largest. Okay. Second largest money comes from their cloud services. And the rest of it is free, like given away. they give away services like Gmail. It's very popular. Like most of us use Gmails. I mean, like more than 90% of you use Gmail. Cloud Genius company, the domain is hosted on Google. And we will do exercises on, by the way, this idea, we'll do exercises specifically, and that comes to a digression I want to call out. All of us need a domain for us to play around with. So some kind of a domain, .com, .xyz, whatever you have. And so like abc.xyz. These kind of a domain name, if you have one, that's great. If you don't have one, I will tell you what to do. We'll have to get one. We'll have to do some exercises. And that can be purchased from companies like Namecheap or GoDaddy for spending like $1 one time. That's the maximum amount that I would like you to pay, $1 plus tax. That's what I would be asking you to do, but I'll tell you how and exactly when, not right now. But a domain is something that you need to have, something like abc.xyz. Do you know what abc.xyz is? http://abc.xyz. Do you know what that thing is? Anybody? Open it up, see what happens. See, go to abc.xyz. What comes up is the Google company, the parent of Google. It's the alphabet, abc.xyz. This is the company that now owns Google. This is Google's parent. So XYZ is a domain, top level domain. They have bought the ABC name for it. So that's what I was talking about here. Get a domain, not this. You cannot get this, it's taken. But get a domain, we'll play with it later on, not right now. I'll describe in the forum. You will have instructions on what to do with that. Next one. Let's go back to finishing up the definition discussion here. So measured service, we discussed that already. Let's move on to the next topic here, which is 3 service models, right? That is in the next page here. First one is software as a service. Next one is platform as a service. And the third one, infrastructure as a service. You saw me examples of infrastructure as a service right here when I was creating a droplet. And at this moment, I want to take a pause. And I would like to tell everybody that I have this bad habit of forgetting to take a break. So please remind me whenever you need a break. Like typically people, take, once in a 3-hour period. Maybe you want to take 2 breaks, that's okay. But take a short break, like 5 minutes, 10 minutes, whatever it takes. But that is necessary. Apparently people have told me in the past that I tend to forget taking a break. I can talk nonstop for and without hoping you don't get bored, talk nonstop for hours and hours. And, I hope you're not getting bored. So if you are getting bored, please let me know. I will make it interesting. But please, somebody take note and remind me to take a break at appropriate time. Maybe after we finish the discussion of this definition, we'll take a short break. I hope I remember at that time. But please, if I don't, please remind me. So we'll continue. These 3 ideas of service models. What does that mean? What does it actually do? So here is an example of Robert. I will answer your question. Please take the questions that you have in Slack, because this iMessage doesn't help. I cannot answer on iMessage in a live session. So take the question to Slack on a one-on-one or a group chat.
That actually was supposed to be just between you and I. I didn't realize you had it just
no worries.
That was off of my phone.
I know. I will say do not disturb here so that I don't get messages. But yeah, thank you. So yes, we'll do that, but later on. So this DigitalOcean example was an infrastructure example. Here is another infrastructure example where I'm trying to configure Amazon Cloud in the EC2 section where I'm trying to get a machine from Amazon. So these are infrastructure services. And a friend of us, I don't know who that was, but he brought up this idea of, take my application and run it for me kind of scenario. So Cloud Foundry internal to your company is what you are running as a platform, as a service. This is the open source application available on GitHub. It is actually sponsored by VMware company, I think Pivotal company, which is also owned by VMware and EMC in Dell now. So they're basically the same family. But this product is open source. I actually contribute to this one. You can see that on GitHub. github.com/cloudfoundry is where you will find the open source implementation of the Cloud Foundry product. This is a commercial product also available to you from the cloudfoundry.com organization. So not .org, but .com. So this is a platform as a service example, which is loading up. The site is not loaded yet. What you're looking at is .org, and the .com will load eventually when it feels like. But while it does, let's give you some more examples of other platform as a service. A very well known is this thing called Heroku. And the idea here is as simple as you described. Take my application and deploy it. So what I want to do is, I have an idea. I will take the idea and the light bulb you see, I deploy it, you manage it, you scale it, and let me use it. None of this complexity. This is the complexity. I want to hide it from me. I don't want to use it. I just want to make use of my application, throw it at you. You take the application, you run it for me, and you don't show me all this nonsense. Hide it. That is the platform as a service. Whereas if you go to the other route, you expose all of it and you actually deal with nuts and bolts, the infrastructure. You will understand it a whole lot better if you do it this way. But if you just want to pay money to somebody like Heroku, they will hide the complexity, let you send them an application, they will run it for you gladly, and you pay them money, they happy, you are happy, and everybody's happy. But in our program, we'll do both. This scenario using Heroku, and the other scenario, building Heroku ourselves. We'll do both to understand what does it take to build our own platform and what does it take to use an existing platform. So this is the usage patterns. This is the building patterns. So you will use infrastructure to build a platform as a service, and you will also be able to, first of all, use a ready-made platform to understand what they're doing. That's Heroku. There are more such examples of platform. The idea behind this definition that we are discussing right now is, where is that? Here, is to this idea of platform as a service. And this idea is actually very, very intuitive. Software as a service. Let me demonstrate that, and you will laugh at me as for talking about it. But here is an example. Some software called Facebook. Like you know it, you use it, it's going to open up, and I will make a post, say hello, like that. And I can make a post. So I'm using some ready-made software, right? Facebook software. Now this is not a commercial service. In fact, they don't charge you for using Facebook. So when somebody doesn't charge you something, what is the product? They're not selling you anything. So what's the product? You are the product. They're selling your information to other people. They're basically marketing you other things. So that's the idea behind this example. But this is not really strictly a software as a service. A classic software as a service that I would like to talk about is something like, let's say, Office.com. So you have this Office application suite that and you have access to it from CloudGenius account that you have, and you have access to your company Office also. But I'll just demonstrate the one I have for my company, which is where I can go use Word document. And you see, I just started Microsoft Word in a web browser. I did not have, actually I have Word locally installed. This is the Microsoft Word locally running on my Macintosh, so I can run it also side by side. But that is not what I'm talking about. My Microsoft Word just opened up. I can start a new Word document and write something. This is like trivially simple, boring work. So I'm going to move it and shut it down. You already know this. What I'm describing briefly, not spending too much time on, is that you can use a blank document to create Microsoft Word document online. This is the Word Online service. And you can write just like you do on a Word document and save it and do everything. And this is a browser window, Safari browser. You are not running the Microsoft Word application directly on your machine. It is running in the cloud as a service. And you can save the file, save as, and all that wherever you want. You can save it locally on your desktop, laptop, or you can save it in the cloud in Microsoft's Drive. It is called what is called OneDrive, something like that. I don't even know their names. SkyDrive, OneDrive, LiDrive, one of those names they have. And so that's what you can save it as, and somewhere save as. And so it goes to some location. So I think it will save locally, but you can save it on the cloud also. So they have some drive service like Google Drive. They have Office Drive. Sorry for let me just name it. What's called LiDrive. If somebody knows the name, please help me.
think it's OneDrive.
OneDrive, yeah, OneDrive, not LiveDrive. I have this old memory of SkyDrive, LiveDrive. It is OneDrive, so that's the name. So that's where it stores if you want. But that is also a service. A storage as a service on the internet is also a type of software service, software as a service where you can get access to storage. This is using the application called Word. This is using a bunch of other applications like PowerPoint and OneNote and Excel and all that, right? These are services available to you as a software, available to you as a service from the Microsoft Office 365 cloud. This is the entire collection of suite that they provide us. All of you have access already, but you probably have this access from your companies already. So that's a different situation. So this is what software as a service is, one example. There are other examples, very, very similar to this Word document you saw online, is this thing called docs.google.com. Very, very similar, competes one-on-one like this. I want to open a new document. I type directly here and I save. File, save as. I can save it in Google Drive or save it locally, whatever I want. This is just like Word, but not really Word. It is called, what is it called? It is called Docs. That's the name, Docs. It's called Google Docs. Similar to this Docs thing, there is this thing called Sheets. Let's see if there is a Sheets thing. Google Apps. Where are my Google Apps? So here are the Google Apps for, maybe this discussion is kind of boring and trivial, so I will skip. But I think you know what a software as a service is. If you do not, let me know that I should continue describe a little bit more on software as a service, but I think it is really, really trivial. So I will vote that I skip the discussion altogether because I find it silly to describe how to write in Word document. So I'm not doing it anymore. So I'm shutting the discussion on software as a service, assuming that you already know what it is. And I don't want to waste your time. So skip. We'll go back to what we were talking about right there in the definition. Software as a service, you understand. Like before we close the software as a service topic, I would like to ask you to like name 2 examples, maybe total of 10 examples coming from you. Just don't repeat an example. Just name services that you know of that are considered software as a service. Just name some.
PeopleSoft.
Beautiful. Next one.
Salesforce.
Yes. Next.
Gmail.
Yes. Email as a service. Gmail.
Twitter.
Yes, indeed.
Spotify.
Beautiful. I think you got the picture. So let's move.
Instagram.
Yeah, thank you. I think you understand. Software available to you, ready to consume. You just pay them some money depending on the terms and conditions and you move on. You just consume. You want to listen to music, you go to Spotify, you play a song, you're done. Sometimes they will make you listen to an ad. Sometimes you pay them money to not listen to an ad, things like that. So that's the software as a service, variety of payment models, and you can, it's more of a business thingy. So you probably understand it already. I'm going to skip. Unless you want to discuss further, you should stop me and go deeper in the software discussion, which I hope you don't, because I find it boring. I'm not boring you. Moving on. Platform as a service is the hardest one to understand, really comprehend what is exactly that thing. And then this third piece is actually simple, infrastructure piece, which is, let's go back to the white sheet of paper. There is a Slack chat message that says nothing.
There's some static or something if someone wants to go on mute.
Okay, I guess there is a question. How do we get the private channel to show up in Slack? Rob says, and I haven't invited you. You were late to Slack. That's why I haven't invited you guys. But let me just do that quickly. So who's still missing on the private channel? Please let me know. I will add you if I am missing you. Rob Backus, I just added you. If I'm missing anybody else, please let me know right now. So you are now welcome, Rob, on the private channel. There we go. Anybody else missing? There's a break time request. That is beautiful. I will like to take a break right now for 10 minutes. Here we go, timer, 10 minutes. And here we start. And there is a timer started already for 10 minutes. It will show you the clock timer right on your display. And let us come back here at the time when it finishes. I leave the counter up and running. I will stay here right now. Don't go anywhere, but you can.
That looks like software as a service.
Yes, indeed. Yes, it is.
Thanks for the break.
Yeah, it is a piece of software. Beautiful. Just search, Google search, 10-minute timer, and off we go.
Nilesh.
Yes.
So in this scenario, like say you saved a Word file online, and you can share this with others, and they can probably edit it and keep it there rather than sending it through attachment, isn't it?
Correct. In fact, that's the benefit of one of those tools that these guys provide is collaborative editing concurrently without having to email back and forth. And you can concurrently edit a document in real time. And the usage scenario is that, if you have like a 50-person sales team and you have you have a particular opportunity where you have to respond to an RFP and you are writing down content together and you have like 5 people attending and basically responding to the RFP at the same time. And you can just avoid any email back and forth. You can just create a Word document or a Google document, any of those 2 technologies, and then share it with your team.
Correct. And also you can restrict them not to edit it, only read. That also is possible.
Right. Also, yes, you can do that. All those permission controls are available at a very fine-grained level. You can control who can read only, who can write also, and who can delete, destroy, copy, share, not share, things of that nature.
So which one is the one which you recommend? Is it 365?
I don't care. Honestly, I don't care. I don't recommend one company over the other because to me, they're all equally good or equally bad.
Okay.
Because this is a vendor neutral course. I don't have any recommendations on a company. Because I don't do that.
But they have the same feature as Word or a Word or Excel.
Word was lagging a little bit behind, but I think Word has recently caught up. I personally like Google Docs, but yeah, who cares? Doesn't matter.
Okay. They're all free of cost, nonetheless.
No, it's not free. Yeah, Office is not free. Google is also not free. Only for educational institutions, it is free.
Okay, so you need to purchase
Google Docs with a Gmail account, but that is not business usage. It's not considered business use. So that part is free. Personal use is free.
Okay.
But for business usage, it is not free.
Okay.
If you want to
like
use
say
it,
some of the companies, they make corporate email IDs based on Gmail. Actually, they are
I have done it. Cloud Genius is one of those. You can see that. Cloud Genius
but can we use it then?
Yeah, you have to pay for it. It's $5 per user per month.
Okay. Sure, I'll take a break and come back.
Yeah.
Nilesh, I just wanted to say thank you very much. You're doing a great job on this.
May I know who's speaking? I just need to know.
Oh, Rob. This is Rob. Sorry.
Okay. Hi, Rob. Thank you. Thank you. Thank you for being kind.
and sorry for sending you a private text. I didn't realize it was going to show up on your screen. I sent it on. I was sending it on your phone, thinking, "Hey." I knew it wasn't going to be answered right now. It's just like I have these stream of thoughts, and I'm like, if I don't get them down on paper or get them when I have them, my brain goes so quick that it's just like I'll lose it. So I wanted to get it out there to you. So we'll talk later. It's not important right now, but it is something that I wanted to throw out there to you.
Indeed. Yeah, we should do that. We should absolutely do that. It's good that you do it, but my machines are all integrated, so I get my phone calls on all the computers.
Okay. I'll remember that next time. I'll just take a note.
Yeah, Nilesh even uses his watch to.
Yeah, I respect Slack on my watch.
So, are you Borg? Star Trek.
This Cloud Genius thing is my hobby. If you did not know this by now, it is. I enjoy this passionately. I've been doing it for 5 years now, and I enjoy it every moment of it. I run the program like 3 times a year, and I, enjoy what I do. That's it. That's all I do in my life, by the way.
Yeah, no, I get that. But do you know what the Star Trek Next Generation, the Borg?
Yeah, that is exactly me talking, right?
Yeah, that's what I was going to say. You're connected. You're a cyborg.
Yes, indeed. I am almost.
Hi, Nilesh. It's Alexei.
Hi.
I'll probably need to escape about half an hour earlier.
No problem.
Cool.
No
Thank
problem. Yeah, you can hang up. No problem. So let's stop the timer, like few seconds left. So I'm stopping it and proceed. I'm just checking if everybody is back right now and doing that in quick second. People are still not back. Okay. One thing I would like to let everybody know that I need to make a report on who's attending, who's not. That I hate that, but I would like to take a picture. I think I will resist for you. I will resist and not actually say, but I want to take a picture of the screen that I'm looking at right now, which is all of you together. And I just want you to know that I'm taking a picture, which means please open the camera and smile.
What if I don't have a camera?
That's okay. Just acknowledge that you don't, and that's fine.
Okay.
By the way, who was that person who said?
This is Rob. I
Rob,
don't.
no
I don't
problem.
have a
Yeah,
camera.
get a camera ready, get ready next time. And I'm just going to take a picture so that somebody will say, give me a report, and I said, oh man, I hate this, but I'm doing it grudgingly. I will resist for you, and I'll stop this reporting. I don't like it. This is silly. But last time they told me to take a picture. I said, oh man. Okay, so I'm ready to take a picture at 3, 2. Let me get ready for the button. 3, 2, 1, smile. Here we go. One more. Okay, enough of that stupidity of taking pictures and reporting, and thank you for giving me the picture. But now let's continue.
What if we're not on there? I couldn't figure out how to get my camera going again.
No worries. Next time, there is always an opportunity. We have 23 more sessions left. No worries.
Oh, I see. Okay, thanks.
We'll do this every time, so don't worry about that. So I'm going to share my screen again, and let's get back to what we're doing. Where was that? Here. Right? We're talking about the two things, infrastructure and platform. So I will describe that without reading this thing. The definition you can read at bedtime when you're not feeling sleepy enough. You should read the definition so you'll fall asleep quickly. That's this definition, the idea of me reading a definition document. But let's go talk about these things called infrastructure as a service and the platform as a service and software as a service in form of a picture. That I will draw it right now. At the very foundation, if you think about them as 3 layers, the foundation is infrastructure, on top of which you will run some sort of a platform. And then on top, you have software as a service. That's the kind of layered cake that I will envision these things as typically. Now, as a consumer, the user is here. They use this service and they occasionally pay them some money and they get usage out of it. That's the usage model from a user's perspective. You play Spotify and you listen to the music and you pay them some money. That's the model. Now, this is a product, or rather a service that they are selling you, but they are the developers of the application that are the customer now, the consumer, and they will pay money to somebody else. Who do they pay money? They pay money to the platform company, and the platform company will give them a place for them to run their application. This application will run and become available to the end user, because that's the model that some of you were talking about before. I am a developer. I have my application. I don't want to worry about all this nonsense under the hood. I just hide it from me. I will give you my app. You just shut up and run it for me, and I will pay you money. Pay the money to the platform company, run my application, and give it to my user. I am happy as a developer. I pay you money. You give me the application, make it go live, and maintain it for me, and do everything that is needed. And don't make me go through this night job. This is like a nightmare, like really nightmare to deal with infrastructure and platform and all. Oh, hide all that. I don't want to see it. No, none of that. That's the model of usage where the consumer is paying money to the application, and the software developer is paying money to the platform company. The platform developer is paying money to the infrastructure company, And that's how the money flows down the chain. The services company will provide an infrastructure service to the platform developers, who in turn will provide a platform to the software developers, who in turn will provide a service of this software to the consumer, who will ultimately consume the service. And the money flows down, the services go up. That's the model of these services. Like what I'm describing here is this definition. That's what they're really trying to communicate to you in black and white in this service model idea. Let's go one step deeper in the picture. The picture again, there is a Slack chat. Let's go read that. What does the Slack say? Okay, I am going to ignore private chats for right now. Stay focused on the group chat here. That's it. So I will ignore everybody else's message. If you really want to get my attention, just pick up the microphone. That's the best way to get my attention. I occasionally don't see the Slack chats coming in because I'm busy talking or describing. So if you want to get my attention, just open the mic and speak. That's the best way. Now, let's go deeper in this discussion. If you further look at this idea of a consumer consuming some service, they give money to the software as a service provider who is a software developer. They give money to the platform developer who develops a platform as a service, and they give money to infrastructure developer. But this infrastructure developer doesn't come up with an infrastructure out of magic, out of blue. They have to also pay money to somebody else. Who are those guys? Do you know who these people are where the infrastructure developer will pay money to? Who are the people? Companies. Companies, maybe. Company. Who are the companies that makes... oh, my typing and spelling is all messed up. But I'm saying companies.
Are you? Would these be the hosting providers and like GoDaddy, HostMonster, those type of companies for the IaaS, the infrastructure, or is
these are the
Amazon, Microsoft, Google.
These are the hosting companies, right? These are Amazon, Microsoft, Google. This is DigitalOcean. This is AWS.
Okay.
Right. DigitalOcean, Vultr Cloud, Google Cloud, and all these cloud companies that give infrastructure. They are infrastructure developers. They give you a ready-made solution for you to get a machine on demand. Like here, for example, you saw this one example here. Let me show you another example, like cloud.google.com. So here is Google Cloud. Google Cloud, you can just go there right now, go to the console, and by the way, I'll give you a link to sign up for. You should get $300 of usage for free from Google with a link that I will find out and give it to you on the forums. You will see that coming up soon at the end of the session. So here you can go to the dashboard and say, I need to get some virtual machines. Can you please give me one? And so I have 2 running already, by the way, here, but I can create one more. And actually, this is my production cloud. So let me just switch my clouds to another cloud. So I'll go to some staging area. So I don't want to mess up with my production. My production is actually running these sites that you look at. So they are running in a Kubernetes cluster in Google Cloud, these sites and a bunch of other sites. But I don't want to mess with the production site. So I just came into a different area, staging area. And here I can create a virtual machine. And I'll say that, you know what, I want an instance in Asia, or maybe US, or I can select the region, Australia, South America, European countries, South Asia, Southeast Asia, things like that. I can pick the place I want. Let's say I want one in Europe West 3C. So I select that. I get my machine CPU size. I can configure the amount of CPU I need. And I can select maybe 4 CPUs. And I can even further customize and fine tune exactly how much CPU I want, how much memory I want. And I can choose the CPUs involved under the hood. So I can choose automatic or Broadwell or later, and select GPU types and a bunch of the detailed configuration, choose my Linux operating system from Debian to some other OS. And sometimes I can get Windows if I like, and choose the disk size I want. And maybe I can get 100 GB disk. And I keep on selecting, and I finally click a button to get an infrastructure. That's the infrastructure solution services provided by Google Cloud for this setup. But under the hood, Google needs to pay some money to somebody else. And those are people and companies that are basically in Taiwan and China. They make the hardware. They are the companies like Flextronics and Compal and Quanta. And you may have not heard of these names, but that's where the hardware comes from. This is the Quanta company, which is, where is the Quanta computer? There, Quanta Computer Taiwan. They make motherboards and machines. This is one. Compal is another one. Compal, I did not type it properly. Compal is another company from Compal Electronics in Taiwan again. If you go to Taiwan, you will see that these guys are specializing in making those big gigantic boxes that you see. Your laptops, your desktops, your iPhones are made by this company called Flextronics. That's what the company that makes Flex.com, makes Flextronics, makes iPhones for us, in everybody on the planet. So this is where the hardware is coming from. So the under the hood hardware, the infrastructure comes from Taiwan, China, and those regions where people are really carved out a niche for themselves in making the underlying hardware for the planet. The world is made in China these days, you know that. That's where it is made, the underlying hardware that is needed by the infrastructure companies, the network, the switches, the storage, the disk, the companies like Hitachi Data Systems. By the way, one of you, our friend, let me spell his name right. His name is Ukash. I think he works for a company called Hitachi Data Systems in Poland. And he makes disks, but Hitachi disks are actually made in Japan, and again in that same region. That's where the disk is coming from. So the underlying infrastructure, which basically boils down to three things. The infrastructure pieces, there are three of them. CPU is one. Network is the second one. And the third one is storage. Those three things together are the components that go and build, or rather build out, an infrastructure as a service that you can then build on top and go this same chain like we're talking about: infrastructure, platform, software, consumer, like that. That's the whole chain of services that you see in this picture. Under the hood, at the very bottom, at the very foundation, there has to be a building with electricity and cooling. In that building, you need to have actual physical machines, physical hardware that constitutes these three things: CPU, network, and storage. You put them together to form a gigantic bunch of machines. You then put virtualization layer on top. A variety of technologies exist. Google has its own. There is KVM, there is Zen, there is VMware, there is Microsoft's thing called Hyper-V, and a bunch of other closed source solutions. But we don't focus on the closed source. We never talk about VMware and never talk about Microsoft Hyper-V because they're closed. We'll discuss other technologies and you will use these closed source, but I will not describe them because they're not open. I stay focused on open source products, which is where most of the cloud is. 90% of cloud people use open source technologies, and that's the best way to remain independent. So with these three things is where we'll go deeper on to understand underlying infrastructure. How does it actually put things together to constitute an infrastructure service? And we evolve the discussion into understanding platforms. We'll also build our own small, but our own platform as a service. And we'll take that discussion. So that's the chain that we like to follow through along as we go in our sessions in this particular segment. Let's finish off that discussion on our definition. So you get the idea of infrastructure. You provide an infrastructure service. So you're basically providing ready-to-use virtual machine solutions, network solutions, VPN, VPC solutions, and storage solutions. So networking technology, storage technology, and compute technology together in form of underlying infrastructure. That is what you will find in most of the infrastructure clouds. In your internal company, in Boeing company, you will have internal private cloud built using OpenStack. That is something that you should talk to Kevin. He'll probably connect you with what they have, what you have internally. Other people from other companies will not have access to it, just realize that. But don't worry, I have a way for you to play with OpenStack yourself, even if you don't work for Boeing, and that way is right here. It is tristack.org. So go here and join the Facebook group like this, click this button and apply. Once you apply, somebody will eventually approve in a couple of days. And when they approve, this will show joined. And once you say joined, you should go back to the TriStack website. And then once you approve your account, you can just try out OpenStack directly by logging in. And this will let you use OpenStack Cloud on your own without being a Boeing employee for free. This is a trial setup. People want, these OpenStack sponsors want you to try open source software, OpenStack. So you log in with Facebook and you actually use this OpenStack available to you for free for a limited period of time. I think they'll let you use some amount of time. So that's what you should experiment with. I will paste this link to you. This is how it looks like from the usage perspective. We'll discuss this at a later point in time. Right now, not right now, but I'm pasting a link in your Slack chat. So you can go TriStack yourself and get approval. They will approve it for you. It is an open source project. You should be able to make use of it. Internally, you have it already in Boeing Company, so make use of that internal to you. Remember to use it. It is absolutely a beautiful piece of software. It is your own company's installation internal. You should absolutely use it. So that's the infrastructure deployment internal to your company. Having discussed this idea of infrastructure, let's go spend a little bit of time on the underlying idea of platform as a service with another example. Here we go. With these three things in hand, we have compute, network, and storage capabilities at disposal in form of some kind of an infrastructure as a service available to us. Now we can on-demand provision anything we need at a click of a button. That's the core idea of infrastructure as a service. So now we want to build something like platform as a service. But what does it actually do for me? And who is the customer of this thing? Like, we want to build this, but before we build something, we need to really understand who the customer is and what do they want. That has to be clear. Without that, we don't know what to build. So we need to find out who the customer is. And you know what the customer is. You know who the customer is. They are software developers. They want to develop their software. They're doing it. They have the software. They want to throw it on top of your platform and make you run it for the end user customer. So this customer consumer wants to use this software. So the software developer will make the software, dump it on your platform, and expect you to run it live and make it go live for the end user consumer. That's the expectation. But if you are building a new platform as a service as a platform developer, you need to know what software we are talking about, what software developers' needs are. And that is the first step you need to really understand before you even talk about platform as a service, right? So now we can do this in the context of an application-specific example. The best way to find out what does the software developer need is to just pick up the phone and talk to them. Hey, tell me, what do you need? That's the easiest way, right? To find out, hey, what do you need? Just ask them. But many times you don't have the flexibility to just call somebody and find out what the needs are. So we have to do some research. So we'll do some research right now. We'll take a pick of an example. We'll use a famous example called WordPress. Many of you have heard of this application. This application is open source, available right here in this website. This is the WordPress application available for download for free from this button. It is made by a person by the name Matt, and he is the creator of WordPress. And I think this is Matt. So he created WordPress. His website is ma.tt, and this is his product. And this product is a piece of software. It doesn't run by itself. It needs something to run. It needs a platform to run. It needs certain things for it to successfully function like a service. So what Matt does is actually runs this WordPress software as a service in a different site. That thing is called WordPress.com. So this guy, the developer of the software WordPress, and by the way, there are like probably thousands of developers together that make the software. It is an extremely popular software. that is used by about 29% of the internet. And that's a massive number. If you think about it, 29% of internet uses WordPress software. It's a big number to think about it. Just by the shape of the size of the internet is huge. And so think about that as to how popular this software is, created by this gentleman and a team of people. And what he does is that his company runs this software on a platform called WordPress.com. And here you can just use WordPress. How do you use WordPress here? You just log in or create an account, and you can just get to a WordPress site. As simple as that. It's just like using Facebook, just like using WordPress, just like using Word document online, pretty much like that. WordPress.com, ready-made service. But this software needs certain things. It cannot run directly on some bare metal machine that you get from, say, DigitalOcean. You cannot just directly run it directly on a Ubuntu box. There are certain things that are necessary for it to function correctly. So if you go to the download page and read the requirements, it'll tell you exactly what is needed to run WordPress. It describes it, because that's what the developer has done, is written down what it needs. So here he describes what is necessary for a machine to run WordPress. And here are the things that are necessary. So let's read that carefully. It says, I need PHP, the language, version 7.2 or greater. Okay. I also need MySQL version 5.6 or greater. Alternatively, I can use MariaDB version 10 or greater. Any of these two, there is a choice available, either this or that. And I also require HTTPS support. That's the requirement. And of course, they also recommend that you use Nginx or Apache as the application server. So those are requirements defined here very clearly with version numbers called out. So now let us take this discussion back to our application. We want to throw this application on some platform, and this is our platform as a service. And we want to make sure that there is this gap between our infrastructure layer and the platform layer. Whatever this gap is needs to be filled up with things like PHP 7.2 and MySQL 5.6 and an Apache server, something like that. So we need these things in between the machine itself and the application that you want to throw on top. So the software that you want to put on top cannot directly go on the machine. It needs some operating system, of course, but then these additional things needed. In classic language, this is actually known as LAMP stack. LAMP. This means Linux, Apache, MySQL, PHP. That's the LAMP stack, is what is described here, is classically the word people use when they say, I need to have what's going on here? I need to have my LAMP stack ready. That's what they really mean, that I need to have the LAMP layer of these pieces put together before I can put my WordPress on top. So there is this machine. I need to get an OS, Apache web server, MySQL database, and PHP language. If I have these things in place, I can then run WordPress. That's what the developer tells you, right? This guy tells you that the requirements are, these are the requirements. So just meet them, and then you can throw the WordPress application on top, boom, it runs. That's how you find out the need of the application. And once you know the need, you need to meet that need. How do you meet the need? You meet the need by making sure that these things exist in your platform. When they do, you have a platform. You have a solution for the application developer. You have a solution for your software developer that they can now rely on you as the foundation, and you can hide all this from the software developer and let them run their application because you meet their requirement. That's the characteristic of a platform. You want to meet the need of a software developer. Whatever they need, you meet them, and you got it. You got a platform there. So now let us look at an example, real life. Here we go, Heroku. A classic, one of the first ones to create a platform as a service. And by the way, opening an account is free on this, so I recommend opening one. Go do that later on, not right now. Heroku, this is the website. It is owned by Salesforce.com, so it's a Salesforce company. They started creating platform for Ruby language developers. So this sign here, the Ruby applications. So Ruby developers will run their applications. They used to run on Heroku, and now they have expanded to cover all these languages. So you have JavaScript, you have Ruby, you have Go, you have PHP, you have Python, you have, this is not Go, this is something else. This is Go. And this is, I don't know what language is, but I'll be able to tell you that. Just a sec. What's the language here? Let's go click on it. Say Java, closure. Now this one is Scala. This one is Go, probably, yes. And this one is Python, this is PHP, this is what? Java. And that one was Scala, I think. So yeah, most of the languages that are modern languages are available on the Heroku platform. So if you write an application in these languages, you're most likely covered already. As long as you follow the requirements of this platform, broadly speaking, your application will just run. As long as you package your application and throw it on top of, literally throw it on Heroku, and Heroku will run it for you, and you will do an exercise on this. It is written down on the website. You will find it, but that's the idea under the hood. So let's go click on the PHP button to be very specific and read what it's trying to tell you. Is that if you want to run a PHP application, you can pretty much go look at this video how to do it. You can do it on your own, but the idea is they will give you underlying PHP and MySQL and Apache server ready, and all you really expect to do is to throw your application on top, and they will run it for you. Literally, that's how it works. Under the hood, they have to deal with all this complexity of making sure that the machines are ready, the right size, the right type, the right amount of disk, the right network connectivity, the right security, and all those pieces of puzzle put together in a fashion that will make your application run, make your application scale as in grow out and shrink back in, scale as in scale up, scale down. All those aspects are available for a price. You have to pay them money to make it happen the way you want. But they, for the most parts, take care of your needs of the application, because they have actually built a business around that idea of running any of these languages, applications written in those languages. You just create an application, you focus on your application, you do not focus on this complex thing called infrastructure, but you stay focused on your idea, you build your application, and you manage, you deploy, and you scale, and you don't have to worry about this. That's the core concept behind Heroku and behind platform as a service in general.
So Nilesh, if you wanted to do the WordPress and they require a LAMP stack, you could go here and you could combine those two things here if you wanted to do that?
Yeah, they will give you a LAMP stack. So if you log in, you will find that they will give you a MySQL account. Let me log in and show it to you.
And then you could use the WordPress because it requires this.
Yeah, you can. Let's go see if we can find a thing to create a new app and say WordPress. And let's see, WordPress, the name is not available. Fine, I'll put this name. And then create an application. And then I define what my connectivity is. I can send the application through Dropbox connectivity or GitHub or Heroku Git or one of those methods. I need to prepare how to send the application, how to throw the application on top of the Heroku platform. And I need to define how the pipeline of me throwing an app on their platform is set. Once the pipe is defined, I need to then call out, literally, let's not jump into the exercise right now, but I want to stay focused on describing the idea. The idea is you have to somehow communicate with your platform as a service company that I need X, Y, Z. You need to write them down, PHP 7.2, MySQL 5.6, and Apache server. I need these things on a Linux box. Can you give it to me, please? And if they say yes, 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 and yes, then I'll say, okay, here's my package, my software package. in a zip file or in a Git repository. I just throw it at you and you run it and you're done. I pay you money, here's my credit card. And you're done. That's the transaction. You don't have to worry about how these things are set up, because that's the responsibility of the platform provider, not you. And so that's the idea behind platform as a service. So we are talking in the context of this definition, and that's what we just kind of sort of did. If you still have questions on this idea of the definition itself, please ask away, because I want to move on to the third aspect, which is 4 deployment models. That's what I want to jump on. Before I jump, I would like to ask you if there's a question on the service models, the 3 things I discussed, which are defined here: infrastructure, platform as a service, software as a service, the 3 things. Any questions of this idea before we jump?
Nope.
Nope. Okay, move. So 4 deployment models. What does that really do? So here are the 4 deployment models. Let me describe this without reading it, because I have read it so many times. So I don't need to read it, but you can read. I'm not reading it line by line. The 4 things here are public, private, hybrid, and the 4th one is community. Public basically means anybody on the planet, open to the world, all of us, like all of the world. That's public cloud. Anybody can open an account on Amazon Web Service, Google Cloud, God knows which cloud. They're public clouds. You cannot prevent people from opening an accounts and using them according to the terms of service. That's a public cloud. Anybody can use. You can use, I can use, your competition can use, like that. Public cloud. Amazon, Google Cloud, Azure Cloud, Rackspace Cloud, DigitalOcean Cloud, Vulture Cloud, Packet.net, Scaleway Cloud, goes on, a list goes on and on. Bunch of companies, hundreds of them, maybe more than hundreds. Public cloud companies. They are public, accessible, open to everybody. You can use it, I can use it. It's everybody's access. No restrictions. As long as you meet the terms and conditions, as long as you're using it appropriately, as long as you're paying them money for the usage, you're good. Public cloud. Next one is private cloud. A private cloud classic definition, you have it in your companies, at least Boeing does, is this OpenStack. I don't belong to Boeing company, but therefore I don't have access to your OpenStack because it is private to you. The limitation is that you have to be a Boeing employee to use the OpenStack deployment internal to your company. Let's call it the Boeing OpenStack, because OpenStack is actually open. I can run my OpenStack in my garage right there. And I used to do it, not right now, but I used to have an OpenStack cluster right there. It is very easy. You just buy this orange box and you run OpenStack in, where is that? Right, that one. Yeah, buy this orange, no, not this. No, on the wrong site. Ubuntu orange box. And so you can buy this orange box and put it in your garage and run OpenStack in like 10 minutes. It's loading. Yeah, you should see this. So that's basically a 10 machine cluster for $10,000. That's what you will see as long as the site is so slow. I hate slow sites, but I should wait for it.
You're loading a PDF. Is that what you wanted?
I know, that's what's going on. So it's a full of pictures, and that's why it takes time. So that's the reason why it is slow. But yeah, I hate waiting. I'm so impatient.
Private clouds are also called on-premises too.
Correct. You're right. On-premises is the, so this is how it looks like. You know, the Ubuntu orange box, it has 10 machine cluster internal to it. It is laid out something like this. And you can run your OpenStack. It is actually designed to run OpenStack for a demonstration. I used to have this box in my home, in my garage some time ago. That's how you run private cloud. It is on your premises. So people tend to use this word on-prem very, very incorrectly. Sometimes they will use the word on-premise, which is wrong usage. The correct usage, like the gentleman, I don't know who was that, he said, this is the right usage. It is premises, not premise. The right way to say it is this: on premises. It is on your building, in your company, in your location, premises, on premises. Most of us in the industry use the word on-prem, on-premise. That's wrong. This is wrong. On premises is the right way to say it and write it. So having said, yes, on premises cloud doesn't have to be private though. That's the challenge. An on-premises cloud can be made available to other people. Like if Boeing decides they want to give me access, they can, but then it is not private anymore because you just opened it to an outsider. I am outsider, right? So that's the difference in between definition of the word on premises. It happens to be at your location, but doesn't remain private anymore because this guy from the Cloud Genius company comes and accesses it because you permitted. If you permit that, it is not strictly a private cloud anymore unless this entity is entirely owned by the Boeing company, which is not the case. You don't own Cloud Genius, so I'm an outsider. So that's why, the definition of private cloud is strictly by ownership and permissions. So on premises is about location, location of where the property is situated. It is not limited to who can actually use it. You can have on premises cloud and still make it available to outsiders. That doesn't make it a strictly private cloud. Next one. Very simple, hybrid. You mix and match. You want to mix and match private cloud, public cloud, you are welcome. Most common cases of this is something like this. I am a company that needs some machines almost all the time every year. That's my minimum requirement. I need to have like a bunch of machines in my company. And so this is my building. I have them. This is my private data center. I have it, my private cloud in my company, and it is different from what I just said. Data center in the company is different from private cloud in the company, and I'll describe that just a minute. But just stand by. The idea is, here is my private cloud, and this is what I have, 5 machines, and I run my business in the company, and things are going okay for the most part. Sometimes what happens is January, February, March, and like that, and comes September, October, November, and December, and like that. When these times come, there is this holiday season comes along. And what happens is my traffic on the website goes high, really high. Because of holiday seasons, lots of people come and transact, do some business. So that's the transaction time when I find that my company capacity in the private setup that I have here is not enough to handle the peak traffic of holiday season. So what do I do now? Should I spend more money and buy 5 more machines to address the need for the holiday peak for the 4 months of September, October, November, December? These 4 months, when it peaks up, so my usage is something like this. Most of the year it's kind of flat, but then these 4 months it's like this, and then down again. September, October, November, December, January, February, March. That's how it goes. So should I buy 5 more machines and just shut up and eat the cost or not? What should I do? Any guesses? Should I spend money, 5 machines extra, and keep them running all the time for the year when I don't need it?
No, get the machine when needed.
Yeah,
that's what we call a hybrid model, where you're doing private plus public.
That's right. That's what I'm talking about. Hybrid cloud. When you need extra machines, you just rent them from Amazon or Google or somebody else. And so in the holiday season, I need 4 months of extra machines. I just rent them from Google and go to Google Cloud. And I'm happy that I don't have to waste my 8 months of downtime or slow days. Don't have to waste money on this equipment. Otherwise, I'm wasting it. So you mix and match private and public cloud. That's one type of hybrid. And this idea, when you need some extra capacity, you want to burst into the public cloud. And then when you're done using the public cloud after the holiday season is over, you shrink back. You scale in, scale back in, you shrink. And when you can shrink, you reduce your cost because you're not paying Google anymore or Amazon anymore, any third-party cloud company anymore, public cloud, you're not consuming, you stop paying, you're happy that your traffic is down, that your machine count is also down. Good. That's the kind of usage which is hybrid, mix and match of public and private. That's one type of hybrid. Another type of hybrid is when you mix two public clouds together. I use Google Cloud. I also use Amazon Cloud. And I actually do that. I use like 5 clouds in my company. They mix and match, and it's a hybrid setup. That's how I have designed. That's what I find most useful for my situation. So I do what I like for my company, or rather I do it what I like for you, because you are the reason why I build these services. I have services for you that you are consuming right now, which is the CloudGNS website and a bunch of other things you will see along the way. But this is done primarily for you as the consumer of my services. So I use a variety of cloud services to optimize my cost. There is some cost to it, to cost of running it. And so I optimize that very, very carefully, methodically, without overspending. Otherwise, I lose money, and I don't want to lose money, right? I want to make money. And so that's how I have structured. So it is appropriate for every company to design their infrastructure equipment in a manner that actually meets their requirements, their business needs for their customers. So you can mix and match multiple cloud companies like Amazon and Google together, or maybe Microsoft also mix along the way, and find out which solution set is better suited for your customer situation, and then mix and match appropriately. That is also hybrid cloud. The definition doesn't agree with me, but who cares? The definition is stale. If you go look at the definition, they may not describe it like that. This hybrid cloud definition, let's go read. It says composition of 2 or more distinct cloud infrastructure, private, community, or public, or they're mixing match. Fine. They 2 or more of the same unique entities that are bound together by standardized proprietary technology enabled, blah, blah, blah. Okay. Yeah, enough cryptic language. You get the concept, the hybrid cloud. Mix and match of 2 different things, 3 different things. But then what is this community business? What is this cloud? What are they trying to communicate? Is that we'll describe this with a Venn diagram. A Venn diagram begins with a big circle. Let's see, the circle is the world. Everybody on the planet. Out of which this is the Boeing company. This is your OpenStack deployment, OpenStack. And here is Boeing employees using it. This is a private cloud. Here is Amazon Web Services. This employee can use the Amazon Web Services directly. That's a public cloud. This is me. I can use Amazon. That's a public cloud. However, this is CIA. And there are a bunch of people. They have a dedicated private cloud for them. It is not on premise, not on premises. It is actually hosted in Amazon. And they're not on premises, but the CIA people are using a private cloud away from them in Amazon. It is limited only to the CIA. Only they get to use it. It is private to them, but not local. It is away. It is a not on-premises private cloud hosted away from them. Another type of usage, the government people, .gov people, anything .gov, all the government employees, they have also access to the public cloud here. But then a portion of this Amazon cloud is dedicated to government usage. That cloud in the US, the government employees, .gov employees, they have access to the government cloud. It's also known as GovCloud by Amazon. By the way, Google also has another GovCloud, just to confuse everybody. But this is the community of people that belong and are workers in the government in the US that collectively use the GovCloud from this service provider. And that's the idea behind a community cloud, where a community of people with a common interest, like helping the US government, for example, use a shared resource available to them from a cloud provider like the GovCloud from Amazon Web Services. Now, you and I don't have access to it because you're not government employees, but government employees do have access. In fact, if you can look at the rate list and internal sheets and pricing structures and the purchase procurement system, you can find that they can actually order Amazon Web Services just like they order supplies from Staples and Office Depot. Pretty much like that. They can consume, they have a standard agreement with Amazon, and they can consume government cloud just like they consume anything else. It's a predetermined contract between them. It is limited to that community of government employees. That's the underlying idea behind the community cloud. Right there. That concludes our 4 deployment models. There can be more deployment models. You can actually, think about it very rationally, and you can potentially come up with another way to classify. And that is all okay. What I want to do now is to not spend too much time on this theoretical definition, but actually move on to the next topic. Unless you have a question, in which case we'll talk about that. Apparently you don't have a question, so I will move ahead. So what I would like to do now is describe the idea of what is virtualization. I think most of you know this already, but some of you don't. So I'll clarify, what does that actually do? Many of you actually ran into this problem in which when you ran the VirtualBox virtual machine, you had a Windows computer made by companies like HP and Sony and some other companies. What they do is they disable, for some reason, disable the capability to run VirtualBox. This capability is in the Intel CPU, AMD CPU. Intel Core family of CPUs and i5, i7 and others. And some of the slightly older ones also have this technology known as Vanderpool, also known as VTX technology. That technology is disabled by default by these companies because they think that consumers are stupid. I hate that. There is no reason for leaving this idea disabled. Absolutely no reason. I found no reason for them to disable it. But for some reason they disable. I don't know why. And that's the reason why your VirtualBox will not work, because this thing is disabled. So that is the foundation technology needed for virtual machines or virtualization to function correctly. You can read more about this in VT-X. If you go search, that's where you can read more on Wikipedia as to what that thing is, but I'm not reading it right now. You can read, by the way, there is a similar technology available from AMD. It is called AMD-V, and Intel has a technology called VT-X, and VIA chipset has a technology called VIA-VT, and bunch of others. So you can read more about these later on. The underlying idea is that this technology, the Vanderpool-like technology, generally known as virtualization technology, this technology enables the underlying operating system, which is Windows or Macintosh or Linux or others, Macintosh. These OSs.
Is that a firmware thing?
It's a processor CPU capability. It's not firmware.
Oh, you can't re-enable it?
You can. Yes, you can enable it. It's in the BIOS. You can just go to the BIOS and toggle a switch. That's it.
Well, and that's technically, this is Rob, that technically is kind of the firmware, is the BIOS is very heavily connected to your motherboard and CPU and all the functionality on your motherboard. So what you have to do is control it through that, but the actual physical, what we call P code or instruction code is on the chip itself.
Yeah, the chip has the capability, the firmware has the ability to toggle it on and off. The firmware is these days known as, what's it called? It's not BIOS
settings.
anymore.
UEFI settings or something.
Yeah, UEFI. Yeah, there you go.
This is the Universal Extensible Firmware Interface, UEFI. And this is the new requirement for Windows. Macintosh had EFI long ago, forever. PCs used to use BIOS. People still call it BIOS because that's what the familiar name is. UEFI is not super well known, but Windows now requires UEFI from starting Windows 8, I think, or maybe 8.1 or something like that. So that's the firmware I'm talking about, which actually enables and disables this capability, which is a CPU capability. Now, having understood that piece, the idea behind this capability is to allow running a machine on top of another machine. You see this live right here. See the machine on top of a machine. Start, run. That's how it runs. You see a Linux machine on top of your underlying machine. You may have Windows under the hood, or you may have, Macintosh or Linux, whatever you're using, but this will run on top of your machine. That's the classic idea behind virtualization.
Nilesh, this is Rob. Are you gonna cover in this class running a virtual machine nested inside of another virtual machine?
Yes, you can very easily do that.
No, I was asking, are we gonna cover that? Or are we gonna play with that at all in the class?
It is right here. In fact, there is this toggle button where you can go to the processor and say enable, the acceleration, nested. Where is that? I think in Windows you see that, not in Macintosh.
Okay.
But in Windows, there is a way to select a toggle button.
It was at the bottom page. It was at the
bottom. You basically expose the VTX capabilities to the VM.
Okay.
Yeah. So you can, just like we expose the VTX capability of the CPU by disabling, enabling in the BIOS UEFI so that the operating system knows that you have VTX. You have to do the same thing in a hypervisor, like the VirtualBox, and expose this technology up a level. So your VM can also run another VM. By the way, we are talking about painfully slow machines. Don't bother trying it. It will be painfully slow and grudgingly, you will hate me for doing this. So don't try it. It's going to be really, really painful. Unless you have nothing else to do, try that. It will work, but painfully slow. Unless you have a big machine like some of you have, like 64 GB of RAM and all that. That's okay. You can comfortably handle those setups. But VM in a VM, slow. That's the way I describe it. Don't bother. Unless you have a big machine with big fat CPU, 4 or 8 CPUs and large amount of RAM, you have horsepower to handle it, then try it. Of course, if you want to see me try, I have another big machine right here. I can show it to you next time, or maybe some other time in an extra session. But I think it is going to slow most of us down because most of us typically have like a 8 GB RAM, not bigger. So I don't want to bother you. So, but nested paging, nested VM in a VM, possible. Modern way of computing is not the VM way of computing, by the way. I just want to point that out. We are talking about these technologies. This virtualization technology is like 50 plus years old, even before I was born. This was known as the LPAR technology in IBM mainframe systems, known as ZOS these days. This is a 50 plus years old technology, not new. And this is going to be soon replaced by container technology. That is what our focus is going to be for the most part. We will not use virtualization too much, but we have to because everybody's using it today. So we'll use it, but not go deeper. And the direction that you're discussing right now, VM in a VM, is not the direction I want you to think, because that's not the direction I want you to go. I would rather cut this VM business all out completely and instead run containers, Docker containers, Kubernetes clusters, which doesn't require a virtual machine. It runs directly on the hardware, and I'll describe that with exercises. You will do that, but what I want to really say is stay away from VM and move towards containers. You will be better off.
So Nilesh,
Yes.
from a Boeing perspective, which a lot of us are, I love hearing you say that because we have stood up and have a large VMware-based virtual machine service that is instantiated and live and running. We're doing the OpenStack right now, and the containers is just starting. And so going in those directions, because we know VM, we know virtual, we know VMware, we know hypervisors and so forth. I think you're, at least from my perspective, and helping the Boeing people move forward, this is excellent. So I appreciate you saying that.
Thank you. Yes, let's put record straight. If I were you, I know it is difficult. I know it is hard. I know it takes time to actually forklift large scale Boeing applications to a containerized environment. But let me go straight black and white. Do it. Like as quickly as you can do it, the better off you are and better off everybody will be. I mean, that's the right way to go forward, is containerize, use Kubernetes, and do that, take that direction very consciously and stop thinking about VM and a VM. Really, literally, I'm telling you this. I have told this to your company many times, but that's the right direction. Don't think VM, think containers. That's the new way of work. You can see one more thing from this search that I will do. Google runs how many containers every day? Let's go read. So it'll search and says right there, everything in Google runs in a container. And this is like 2014. It says it starts 2 billion times a week. That's the news. Containers, 2 billion containers started every week in 2014. We are in 2018 right now. So just remember this. Absolutely everybody should move. I know it is difficult. I know it will take time. It's not going to be magic. It's not going to happen tomorrow, but please make it happen. Think in that direction and go that direction. That's what I'm going to push for. And I have, by the way, the whole program that we have has been reformed, reshaped around using container technology. Cloud Genius services are running in Google Kubernetes clusters, as you may have seen briefly, and I'll show you that. Cloud.google.com. You can see that live. Here is my console, and here is my production, that one. And here are the Kubernetes clusters where you can see the Kubernetes cluster running. You can see workloads running, and you can see a bunch of detail. I'll show you these things, but bear in mind, containers, no VMs. Thank you. Let's move. Back here, we are talking about virtualization just to make people understand what it is, right? That's what we are doing, but we'll quickly switch to containers as soon as we can, as soon as it is logical. Now, having said, I also tend to forget that it is the end of the class. So if I run over, please ask me to stop. I have done that many times. I keep on going. So I think I just noted the time. So it is, we still have 30 minutes or so. So no worries. Let's understand this container technology, see what it does for us. And so we can then compare, contrast what a VM is versus what a container is, and how do they do and how they behave properly and differently and all that, and what the benefit and pros and cons and things like that. And that's the kind of understanding I want to build first. So VM again, this thing allows you to run a complete machine on another machine. A complete machine on top of another machine. Let's go see what a complete machine is. It will have its own power button. Let's begin from that. So like every machine, there is a power button, not this. Let's see where the virtualization, what am I opening? This window is wrong. Okay, go away window, that one. Now bring virtual machine, please. VirtualBox. Here it comes. So here is this VirtualBox machine, which I have created for you. You also have it. Let's go look at the settings. In there, you will find that it has a power button right there, green colored. Start, click to start, power on button. Let's go settings, examine, details, system. There is a CPU, right? The processor. I can get more CPUs up to about 4. I have total of 8 CPUs available, virtual CPUs. I can allocate up to 4 CPUs to this VM. I can also put an execution cap at a certain % level. I can also provide acceleration and use the underlying hypervisor technology. There are 4 or 5 different types. I'm using the default one. Next one is the motherboard. I can choose the type of motherboard chipset I want. There are 2 choices available. Here I can add a hard disk, I add an optical disk if I want, or remove, add a floppy disk or not. add a network card extra or not, and the boot sequence, I can arrange that. Similarly, I can also choose to have a display connected, an external remote display if I want. I can set a video card. I can also decide that I have some storage allocated. The storage currently is a disk that is currently an optical disk is empty, and a physical disk is this one, is a disk of 127 gigabytes in size, but the actual size is only 12 gigabytes. That's the actual allocation of disk space given to this virtual machine. Let's go forward. Audio. There is a sound card from Core Audio, or you can use a null audio driver. There are audio controller selections available, Sound Blaster or Intel HD Audio or ICH, those 3 technologies for audio. Similarly, there are network choices. There are 4 network cards possible in this design. You can have only up to 4 in this application. You can connect this adapter number 1 in a network address translation device, or there are other modes of connecting. We'll talk about this also later, not right now. The adapters, other 2, 3, and 4 are not connected. We can have other additional ports, like I can have a serial port or a USB port connected or not. I can choose the technology of USB 1.0, 1.0, 1.1, 2.0, 3.0, depending on what my choices are. But I don't think I want USB, so I say, no, I don't want. I can also enable shared folders and some user interface features. But what we just saw is a machine definition that shows up like a set of files in your computer in this location. What does it look like? It looks like this. Practically, it has these 4 files. There are some logs which you can ignore. The actual disk is this file, and this disk is about 13 gigs. This prev is a snapshot, so we can talk about the snapshot later. But this is the definition of the box itself. This is the CloudGenius VBox definition. Let us, for the sake of understand what this definition actually is. So what I want to do is edit this file in an editor, and to see and examine how is the machine defined in software. We are talking about machine on top of machine. So this is the VM on top of your machine, actual machine, the real machine. This is the fake machine. So the fake machine is actually defined in form of a file that looks like this blue colored box, VBox file. Let's go open that file and see what it contains. So I am going to open up an editor, and in that editor, I'm going to see if I can open that file. Open, which file I want to open is that VBox file, which I was looking at right now. So I'll go to my CloudGenius, VirtualBox VMs, workstation, and that blue colored item right there, this VBox file. And I'm going to open this VBox file in a text editor. Just remember, text editing. This is a very small file, 5 kilobytes. We can actually open this file in an editor like this. And you can say that it's warning you, do not edit this file. But let me see what it actually contains, because I'm curious. So I'll find out what it contains. And you will see that it actually contains every single thing that we would expect in a physical machine. For example, it describes in line number 12, the hard disk, line number 12 through 14. The DVD connected, which is not really connected, but it's available. It actually has this ISO file mounted as a DVD. There are some extra data available. This extra data is basically the power off. The last close action was power off. Last guest size hint was this. So some random characteristics needed for the function to function. You can also see that the boot order, indicate order is this sequence: hard disk, optical disk, floppy disk, network. That's the boot sequence you define. Next one is CPU. You have a physical address extension enabled is true, and bunch of other hardware parameters are called out right there. You have a memory size called out 2048. You have a boot order. I think this is not the boot order. This is the boot order. Order position number 1 is hard disk, then DVD, then none. You have a virtual RAM size 128. The video RAM, not virtual RAM, video RAM size. There is a remote display property. There is a BIOS definition enabled true. There is a network adapter number 0 is enabled, but then all other adapters are not enabled. There is a sound card defined. There is a clipboard bidirectional, drag and drop bidirectional defined, some guest properties defined, some storage controllers defined, and that's the end of the file. So this file you look at is actually an XML file. XML is a format of files as to how you describe certain things of the machine that we are talking about. So what we are looking at, this machine is actually a fake machine defined in this document. It's a 5 kilobyte XML document with a VBox extension that VirtualBox software understands. That's the reason why you have this warning at the very top saying don't edit it, because it is not created by hand. Some software wrote it, so you don't want to mess with it. You want to let the software handle it. That's why I wanted to examine what it contains. So it actually contains a definition of a machine. And what you notice is that it actually has all the things that you would expect to see in a real machine. It is there in a fake form, in a virtual form. You can actually turn off, run an OS. And if you don't have an OS, like for example, if I right click and remove this and say delete all the files and it's gone, now I don't have anything. Now, if I want to create a new machine, what do? I go click new. And then I define. Now, this is what you have not done before, because what I gave you is a ready to use, ready to consume virtual machine from the CloudGenius download process. You have it running, but what if you don't have any? What if you begin from scratch? What do you do now is you actually create a new virtual machine just like that by clicking this button and say, give it a name. I want to run my OS. So I'll call it my operating system. But then what is my operating system? I can choose what I want to run here: Linux, Solaris, BSD, IBM, Mac OS, or others. You can run your own operating system if you have one. You can also run Windows if you have a Windows license. Now, Windows requires a license, and I don't have a handy, so I'll use Linux. And I can choose which Linux I want. There are a variety of choices. Maybe I will use Debian Linux, 64-bit. And I continue. And then I get to select how much memory do I want to allocate to this box. And I can decide that I can give it more memory than just this. I can go all the way up to this point, because beyond that point is the red marker, which basically is an indicator that if I go beyond this like that, my actual Macintosh performance will degrade. I don't want to go in the red area. I want to stay in the green area, which is okay. I will have my Macintosh enough room to breathe, while at the same time being able to give 12 gigabytes of virtual memory to the virtual machine. That is okay. Typically, I give like 2048. Sometimes if you have more, I give more. But no need to go beyond this line, because then you're crossing the red area, which is not a good idea, because the machine under the hood, the Macintosh OS in my example, needs breathing room. It needs to survive. Otherwise, it will die. And if the machine under the hood dies, your VM is also dead, pointless. So don't go that direction. Just stay within the green area like this, for example, and continue. Now you can choose to select a hard disk. Now, before we select a hard disk, I want to point out something. On this Macintosh, you have some storage. And how much storage do you see? I have about 1 terabytes of disk, flash storage, right there. 1 TB total available, right? You saw that. Okay. Now, I will ask you a question. Can I create a virtual disk here and say that I want to get a 2 terabytes of disk? Is it possible? Can I get a 2 terabyte disk for this virtual machine?
Yes.
Sure.
Yes. Some people say yes. Is there anybody saying no? But I like to ask this question because I want to clarify one thing, is that this storage available is only 1 terabyte. And how in the world can I get 2 terabytes to this machine when I don't even have it? That's the question now.
This is Rob, because you selected dynamic.
You're right, sir. Absolutely. Bingo.
And there's compression.
Bingo. Bingo. So the point Rob is clarifying is, if you go back a little bit, you will notice what I just did, which I kind of did quickly so you don't see it, is that this idea of dynamic allocation. This allocation basically allows you to allocate more than you actually have. So if I go through the 2 terabytes number like this, it will let me create one. The actual allocation is not going to be 2 terabytes. In fact, it's going to be like few kilobytes right now, because there is nothing actually consumed. Now, for real, if you actually keep storing data on the disk, on the virtual disk, and if it goes beyond the actual physical available 1 terabyte, you will have trouble already. But This is dynamic allocation. It is illusion of 2 terabytes. It is not actually 2 terabytes are not possible. You don't have the storage. So it is creating an illusion of storage larger than it actually is. That was this my OS powered off shows in the settings where I created a system with some memory allocated, some processor selected, maybe 2 CPUs and some acceleration chosen, and PAE physical address extension, no execute bit set. Storage, display selected, display video RAM I increased, remote display I don't want, video capture I don't need, storage I selected as 2 terabytes of disk. This is like 2 terabytes in allocation. Actual size is 9 megabytes, very, very small, which is exactly what we expect it to be. You will see that audio sound card I don't need in the video machine, network card I need only one of them, connected ports. I don't really need to have port access to this, so no USB, no serial ports. And that's my machine definition. Now, if I click OK on this and I say start, and I have chosen Debian OS in my settings, if you remember. If I start this machine, what do you think will happen? Will you see Debian? Will you see a Debian operating system pop up out of magic?
No, it will not. It will say it is halted.
Correct. It is going to not give you anything whatsoever because it is pretty much similar to you going to like Fry's Electronics in the US. Fry's, and you go assemble a machine on your own, like get the CPU, get the disk and all that, put pieces together, power it on, and what do you get? No operating system found. I don't have an OS to run. So give me an OS so I can actually run. So you assemble a hardware, you still have to provide an operating system, which we haven't done yet. So if you start this VM, it will exactly behave like you would do in other cases. Like we will start the machine, it will say no OS found, and it will halt. Right there, no bootable medium found, system halted. Because it doesn't know what to do, doesn't know what to run because you haven't given any operating system. So we have to give it. How do you give? You say settings, and then go to the optical storage disk area right there. And this is some guest additions, so you want to remove them. Instead, you click on this image and choose a ISO image of Debian operating system. How do you get the Debian ISO image? You go to debian.org and download the image right from somewhere here. Where is the download button? Network install. And you go small CD USB and AMD 64-bit, and there is your CD-ROM. No, hold on, I think I went to the wrong location. NetBoot is not the right one. Maybe this one is the right one, network boot. So this is a solution that you will have for network boot, and you should get a medium from this file, a mini.iso. So we just downloaded it. That mini ISO is coming down 40 MB, and that's what you need to get, and then provide a link to this image in that virtual machine. So you have to go click this button, choose the disk image that you downloaded from the downloads folder. So click here and then download, and that's how you get to what you want. So then next time when you boot up this VM, it will actually attempt to install the Ubuntu mini.iso, which I am still downloading. And it's not complete yet, so I haven't been able to give it the image that I wanted to give, but that's what is expected of a virtual machine. This kind of an image that you saw, I download from the Debian website. You can see that the download is actually finished, so I can potentially maybe give it that link and just demonstrate that piece to you, that how you actually do it. So guest ISO additions, I don't want it right now, so I remove that and instead make it empty again. And I go again here. So select, choose my ISO image. In the download section, I have this file and I say open. And now I say okay. And this time, if I now boot like this, it will say starting Debian installation. And there we go. And then I can click the buttons to actually finish installing an operating system by following the sequence. It will take like 10 minutes. I don't want to do that, but you get the idea. You need to provide an OS. I'm not actually setting it up, but you can do it. The idea that I'm describing to you is a virtual machine is actually a complete fake computer that runs just like a physical machine, except it is actually a collection of files that look like this. Where is that? Look like this. This is how it looks like. There is a logs that you can delete comfortably. There is a VDI disk image, 9 MB disk, which actually is representing a 2 terabyte disk, just a file. This is also another file. This is the machine definition, VBox file, the blue file, which describes what the machine characteristics are, which you saw visually in the settings section. The same thing is described in that file in XML. That's what a virtual machine actually is. It is completely fake, make-believe, pretend game, like kids play, right? Pretend game, that's exactly what it is. They make believe that it's a machine, but let me tell you, it is not. Just a bunch of files. That VTX technology that you saw, that we discussed, actually reads those files that you're looking at here, these files. That VTX technology will enable illusion of a machine, a complete machine with its own isolated environment. And the core characteristic that you see in a virtualization setup is the property of isolation, where a thing running inside a VM does not impact anything under the hood. So under the OS, underlying operating system, whatever you have, anything you do here does not disturb this. No impact at all. It's isolated. If you configure it correctly, you can get internet here, but it has to be provided by the underlying machine. There has to be a way to connect. And next time, when we get together, we will discuss the networking capability of this machine at an individual level, and then extend this idea to a cloud setup to understand larger complex setups. I'm using this example of virtual machine right now to simplify our understanding and get us a clear idea of what this thing actually is from a usage perspective. And then we take it to the cloud and see more complex designs. There is a ton of exercises for you to do, and stay focused on understanding and doing and making sure that I don't bore you. That's my primary goal. Let me clarify one more time. I do not want to bore you. We still have some few minutes for us to conclude the discussions. I will do that. I'll also tell you a couple of things to do before the next session. The next session that we have is not Monday. Not Monday. The reason it is not Monday is because Martin Luther King Day in the US. It is a holiday, and we have decided to not run a session that day. So on the 15th, it's a Monday, so sorry, January 15th. What am I writing here? 15th, where's the calendar? Where's the calendar here? Right there. So 15th of January, no session, please. Just remember that. I'm there, I'm here, I'm on Slack, I'm on the forum, I will answer your questions. If you want a one-on-one, I am absolutely available. It's just that we don't have a session that day because that's what Bellevue College wanted. So we don't have it, fine. I'm there, I'm not going. I'm here for you, here with you. You want to work, I will work with you. This, no session, just remember that. The next session is actually Wednesday. That's when we will meet at 4 p.m. Pacific time. Please translate your time zone. You know that how to do it. And that time, we will actually continue the discussion and take the next forward steps. And on that day, what I want to be able to do is to go further and go deeper in more specific examples as it applies to using a cloud. For that to happen, I need you to do certain things, and I will describe what I want you to do. So I will write that down. First thing, create cloud accounts without spending money. Cloud services accounts. That's one thing I would like you to do. So first thing, Amazon Web Services has a free tier. Use that. Google Cloud has I think some free usage for I think about $300. Use that. And third one is DigitalOcean. They have a coupon for about $10 of usage. That is enough money for our purposes. So we use that coupon. I'll give you links to these things. You will see it in the forum somewhere in this site. In the forum section, that's where you will see these answers, these things to do for you. They will show up here in this page when you click the forum button. So right there, forum, that's where you will see what to do in the downtime we have from now until 17th. What to do? That's what I'm writing down right now. I will also post this on the forum so you have ready access to it. So some free cloud accounts to begin with. We'll add more clouds as we go along, but I will stay focused on do not spend money. It is all free. Remember that. Don't waste money. I'll describe more. So that's one action. The second action I expect you to do is to choose or select a domain name for yourself. And this is something that I strongly recommend. And in fact, we will require this in an exercise we will be doing, because what I want to be able to do is to connect your domain with a bunch of services that you will create, and we'll have exercises to do. It is absolutely nice to have your own domain connected to your own service to really get to the point of how things happen in real life. And therefore, getting a domain is necessary. It will cost you $1 plus tax. You need to go something like here and say $1 domain. So just domain should get us a coupon, right? So you just search for domain, or not domain.com, go domain name. And GoDaddy should automatically prompt you with an advertisement saying 99-cent domain right there. So use that link and then get in. You will get one domain for 1 year for $1. At the same time, GoDaddy will try to sell you with a bunch of other things. Don't buy it. Do not buy it. We don't need anything whatsoever. Just the name. That's all we need. So buy it, but remember to buy a name that you like, whatever you want to put here, and whatever you want to put here after the dot. Like, for example, when I wanted a domain, I wanted to get the cloudgenius.com domain. So cloudgenius.com, I could not get it. So what did I do? I said, okay, if I don't get it, no worries. I still get the Cloud Genius name. How do I get it? What did I do? Do you know? You probably know this. You have seen it. I'll just illustrate that very clearly like this. So what I did was I wrote the name Cloud Genius and then moved 2 steps back and put a dot in right there. That's the domain I bought. You can get any domain you like, but get one. And remember, do not spend more than 0.99 plus tax. And tax doesn't apply to Singapore and yeah.
Nilesh, this is Rob. I already have a domain and I'm already running a number of services on that domain. Are we going to do anything that would disrupt that?
We are not disturbing your domain, but we are okay using your domain by creating a subdomain. We'll play with it.
Okay. Okay, so we'll do it subdomain.
Yeah,
okay.
we subdomain and play with it. We just want to play. We want to understand. We want to make use of.
Okay.
This is the reason why we are using a domain, is because we want to actually put things to work, to see how real life happens in the cloud, which needs a domain name to begin with, like some kind of an anchor for you to connect your services. That's what I will be doing. So if you have a domain name, use it. Create a subdomain. I'll guide you how to do that if you don't know, and play with it. And eventually you might get some ideas about using your services. I'll bring up so many examples that some of you might actually adopt those services like I described, but it's your choice. You don't have to, but definitely do practice, for which you need a domain, not which domain you like. Don't buy a fancy domain. There are more expensive domains available for more than $1. Don't waste money, but get a domain, some domain that you like, that you actually can get. So not domain.com is taken. So that's the second step. There is a couple more things I want you to do, and that is to remember to not get drowned in the number of tools and technologies that I tend to use. I have this habit of using everything available to me. And in my company, we have almost every known cloud service available at our disposal, but don't make that drown you into what I call tools and utilities nightmare. I am known to cause that pain of too much information or too many tools and utilities. So what I'm doing to do is to narrow down the focus and not dilute your attention to too many things. What I'm really trying to say is you need to remember a few passwords. and I will list them what you need to remember. One is the Cloud Genius website password. You should know that already. The Cloud Genius website is kind of clumsy. It is b.a.cloudgenie.u.us. So it's a clumsy name, but Google search Cloud Genius will bring it up right up front. That password you need to know. That's one. The second password you need to know is the Slack password. These are the two that are required. Everything else that I talk about, hey, get an access to this or access to that, or access to Office 365, access to Google Cloud, access to Google Storage, access to Facebook for Workplace. Oh my God, I will drown you with information. You can consider all of it optional. Optional. Everything else is optional. These are the two sites that I want you to focus on. Is Cloud Genius Forum, which is already linked up, integrated right there. You can see that it is already connected right there through the same login, and Slack for interaction. That's the two things you need to remember for password purpose. I've given you Office 365 passwords. I will also let you know that you can use the same password to go to gmail.com and use all the Google services also using Office authentication. So we have integrated authentication centralized with Office, that you have Office 365 password. By the way, all of this is optional. Don't have to do it. Just remember, only these two are critical. Everything else I'm describing to you right now in the next 2 minutes is going to be optional. Don't have to do it, but just telling you that you can. Office 365 is where we centralize our login and passwords. It's our central ID authority, our Active Directory. That's where you have logins to that portal.office.com. Using that same login, you can authenticate to a bunch of services. For example, all of Microsoft services, all of Microsoft Office services are available to you. You also have all of Google services available to you. All of Google Suite, GDocs, Gmail, unlimited Google storage, all of that available to you even after the boot camp is finished. You still have access to it. You also have Workplace from Facebook also included with the same login authentication. It is available to you at a location cloudgenius.facebook.com. And so it's a separate site, again, optional. And there are so many things I don't even remember I have. They are available because these big companies are generous in sponsoring educational institutions they want us to use, so they've given it to us. We have them. I'm not enforcing or inflicting it on you. Don't have to use it. In short, ignore all this. Don't do it. Just stay focused on the key thing, which is the actual site that we are talking about, the content that we are going through, and Slack is for interaction. So the two passwords I want you to remember. And if you miss the password, you can always reset the password. No big deal there. Every other tool, pointless. You can, of course, use it. You're welcome to use, and I'll help you if you need that. There's just too many tools available. So you might get automated emails in your Office 365 account saying, hey, use this or use that, because they're giving it to us and it's making available to everybody. But don't get your focus diverted. Stay focused on the Cloud Genius website and Slack chat for interaction, and work on the pathway. That's the bottom line I want to say in terms of passwords and access control. Okay, so for the next action, remember to create accounts in these three companies at least to begin with. We'll add more later. And get a domain. And we will get together again. We will get together on January 17th at 4 p.m. Remember, 15th is not a session, no session. I am still here. I'm working all the time. I'm here on the forum and on Slack. And let us continue what we are doing. If you run into a question, if you want to finish a setup, you need some help, you want to create these accounts, look at the forum. You will find links there, and please open up accounts. Don't spend money. They will give you free usage worth of $300 and $10 on some other sites. And this is like 1 year free, 1 year. So use these accounts, use these freebies available for our purpose of the bootcamp. This is enough money. We don't have to spend money on cloud services. The only money I expect you to spend is this $1 for getting a domain. It will cost you money. And that is something that I recommend. If you don't even want to spend that $1, I have a way. It is called Freenom, but I don't recommend that. Freenom. So it's a free name available, but that is not what I recommend. It's there. You can get it if you like. If it is available, take it. Freenom.com. If you want a domain, go ahead, take it. I don't recommend this method, but just calling it out. It's there.
What is this is Rob. What is the reason behind why you don't recommend this? What is the detriment to this? What's the
the detriment is that you don't own this name. It's a rental. That's the bad thing. Yeah, that's the bad thing. It's not a ownership. It's a rental. You just get to use it, and they can take it away from you, which is a bad thing, right? You own a domain. You want to control it. You run your business on it. So if somebody takes it away, what's the point?
Yeah. Okay.
That's why I say don't use it, because you know what? Somebody might take it away from you. That's a bad thing. But other than that, it's okay. It's $1. I mean, I would spend $1 and get my own domain if I don't have it. Make sense? So now, bottom line, how did I do? Did you thumbs up, thumbs down? Give me a quick one. How was it today? Was it useful? Was it relevant? Was it boring? Was it not enough? Thumbs up, thumbs down. Either way.
Thumbs up. It was good.
Oh, thank you. So thank you very much. If you don't like something, please tell me. I really, really want you to tell me that, hey, don't do this. Do that instead. I will take that feedback gladly. Remember, I'm not a college professor. I'm more like you. Please tell me to improve. I will improve. I promise. Thank you.
Thanks,
I'll stop recording now. I'm still here.
Thanks, Nilesh.
Thank you.
Thank you.
Good night.